Alright, hello. Things should be working. I can close some of these. The biggest thing that I need to get done today is study. I'm going to do a Leetcode question before that though, and then try to get some study, a lot of study done, probably like 2 subjects, before I continue with my scheduler development. So the chances that I actually do scheduler development, we'll see. But yeah. Oh, Zahib Hassan, you already joined. Hello, man. I'm good. Just about to get started in the day. Oh. Cause somebody stole my car radio and now I just sit in silence. The camera is not clear. There's too much light. Yeah. This is just how I've set it up for some time. I can't be bothered changing it. But yeah, when it's night it's fine, but yeah, when it's daylight the exposure's off, you know. Just pretend you can see my face clearly. Instead of Python, it's code in C++. Anything to cover the light, like some curtain. The curtains are too big to actually close. We actually have never bothered closing it. Plus, it's natural light. I like it when I'm sitting here for so long in the day. I apologize for the camera quality. Oops, I can't get this. M is, oops, M, just moving the camera. I could move the camera, but the problem is I want to respect some of my other family's privacy as well. So seeing this way, you can only see so much. And you know, there's a computer behind me, but I'll be blocking it, so whoever sits there is fine. But then you can usually see like other people walking upstairs and stuff. So if I turn the camera a bit, but yeah, that's why, basically. Yeah, no, I can't be bothered now. Alright, let's do Leetcode. Needcode. We'll do one question. Trees. Subtree of another tree. Okay. Given the roots of 2 binary trees, root and subroot, return true if there is a subtree of root with the same structure and node values as subroot, and false otherwise. A subtree of a binary tree is a tree that consists of a node in a tree. It consists of a node in tree and all of its nodes' descendants. The tree could also be considered as a subtree of itself. 1, 2, 3. This is true. And then this is also true. Oh wait, false. Subtree, it has to only be... Yes. Okay. Number of nodes in both trees is less than 100. I will also have a look at the Leetcode question exactly. Also open up Obsidian to the side. Let's just move it across a little bit. Okay. New subtree of another tree. Given the root of two binary trees, root and subroot, return true. Wait, so root and subroot. Return true if there's a subtree of root with the same structure and node values of subroot, and false otherwise. A subtree of a binary tree is a tree that consists of a node in tree and all of its subnodes' descendants. The tree could also be considered as a subtree of itself. You can access hints, topics, tree DFS, string matching, binary tree, hash function. You can see companies. I didn't know Leetcode did this. Hint 1, which approach is better here, recursive or iterative? If recursive approach is better, can you write recursive function with parameters? Is this not just giving you the solution then? Partially. The discussions here. I mean, the code is not the longest, but it would come up as not trivial. What do you all think? Interesting. I want to just write it here, to be honest. You know? Maybe I'll move this to this side. How would you go about this question? can you assert that the number of nodes in trees and the root val, subroot val is between -100 and 100. Are we considering that the value, so we have to match by the value possibly. Alright, so number 1 is matched by the actual node value, but let's see, so if we go by a DFS, right, you find 2, say that's 2, and then you check 4, that's the same, you check 5, that's the same, and both, since they're both leaves, you know you have the whole subroot, so then you return. Otherwise, when you uproot, if you have something like this, you get to the 4, and there's a subnode, whereas this is a leaf. So then, you know, you can't do that. So that'll be it for this 2, and then you would go to the other side and see 3, and that's not 2. So you wouldn't do anything there, unless, you know, m plus n, maybe, you know, you find the 2, right, that's this value of 2, and then you say, you know, once you find that value of 2, if it doesn't exactly match this, then you can't do anything. Okay. Okay. I have an idea. If you're going to do DFS, then you probably have to specify DFS of root of a node and you do DFS root subroot possibly. I mean, that's kind of literally what I'm doing. DFS or BFS? It doesn't matter. But if you do DFS, Ooh. So you return. That's my original thinking. I know I don't need to do it like this particularly. Is same tree. How do you check if it's the same? I don't know, you can do a BFS, I guess. Or a DFS. And if anything's not the same, then you just return. But is that not at most assuming there's only ever one? Doesn't matter. Alright, let's have a look. Is subtree, if not subroot, if not root, if self, root and subroot, return true. Otherwise, self is subtree, root left, subroot, or so yeah, you don't need an external DFS here. back. Let's have a look. So if node how much am I missing? So if root is none, return false. If subroot is none, return true. If self same tree okay. If root equals subroot, return self same tree root subroot. Otherwise, left is subtree root left subroot. Right is root right subroot. And return left or right. That is literally how I've written it. And now you need the function for is same tree, which if I just try it, n1 let me think. n1.val is equal to n2.val. If n1 let me see, compared to binary trees, right? If the left binary tree just do a DFS again, or just do a stack. Ugh. It's my choice, I suppose. But will you n1 val, n2 val, if n1 val is equal to n2 val, does not equal to n2 val, think that's right. If not root and not subroot, return true. If root and subroot and root val equals to subroot, otherwise you return false. But if it does not equal to, then it means, so if n1 and n2 is equal to none, otherwise it's not none. So return same tree, left, right, left and left, and right, right. This is right. Okay, this is right. No. I was too confident. I was way too confident. My output was false when it was meant to return true. Okay, let's have a look at the input. Try and recreate the solution. So if not subroot, return true. If not root, return false. If root equals to subroot, then you return true. If root does not equal to subroot, is same tree is not defined. What? How do you mean is same tree is not defined? Well, that's incredibly sus. Hello. Did I spell is same tree incorrectly? No, I didn't. Hello, Dukmin. Nice for you to join. I'm figuring out a very puzzling problem. Name error. Name is same tree is not defined. And yet, is same tree is defined. It couldn't possibly be that it has to be before the solution, does it? No, no. Control, undo. What could possibly be causing this error? Is same tree. Is same tree. Highlighted in 3 different places. It's calling self.is same tree, but it's not. Being recognized. Let's just call it same tree. Unbelievable. Refresh. Why? 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 What in the world? What in the world? What in the world? Am I missing? Am I just lost? I feel like I'm lost. That's not it. It's not copying this properly. Again. Is same tree not defined? Oh my god. I was looking at the wrong place. This whole time I was looking at the wrong place. Okay, valid. So if none and none, you never guarantee that n1 and n2 exist. N2 left, so N1 left and N2 left. Is this not problematic as well? You don't know if it's a none. If it's a none, then it's going to have problems, no? Say then it's equal to that's it. No! Alright, what am I missing from this solution here? What the... Right, so you can have multiple of the same value. It doesn't necessarily mean that... Fire Emblem. Can I believe I get to see my favorite streamer live? Hello, man. I saw your other comment the other day. That was very wholesome, and I thank you very much. You motivate me. Yes, sir. Okay. Well, that solution is solved. You motivate me. I suppose it goes both ways. Okay. Submit. That should be fine. And then wsl.exe. It's gonna load. All right. Add 400, what is this? 572. 572 subtree of another tree.py. That's pretty. Control Z. Undo. Just undo all the way. We will code this up. How do you get Neovim to have that aesthetic, and what terminal do you use? I'm trying to get into Neovim, but just have not gotten around to it. Yeah, so this specific Neovim, I'm using a specific thing called NVChad, which has its own docs as well. I guess before I even, knew about NVChad, or before I even started installing NVChad, I also didn't know anything about Vim, by the way. So this small tutorial goes through some stuff, such as go through Vim Tutor to understand Vim, right? So I did that, and now I'm just using Vim now a lot of my time. And what terminal is, this is called Alacrity. But the thing is, I have problems with actually copy and pasting code. From Control-Shift-V, it pastes it, but there are indentation errors coming from the web, coming from, copy and pasting from the web. So that's not very cool to me, and I don't like it from Alacrity. So I think there's still some problems with Alacrity on Windows, but I'm using it anyway, because why not? Pretty much used every major IDE and text editor except Vim Lamel. I'm gonna guess you used JetBrains. Oh wait, what's it called? JetBrains. Oh, what's it called? I forgot that editor name. I think it's JetBrains, maybe? VS Code. The other one, maybe Z. Is it Z? I think it's called Z, which is a newer one. That was such a huge help. I cannot thank you enough. I had heard of NVChad, but wasn't sure if that was where to start. VS Code, IntelliJ. Yeah, IntelliJ is what it, yeah. And PyCharm, yeah. I've tried PyCharm as well in my early days, and then IntelliJ, I had to use it for a Java project. VS Code is what I mainly use now, or what I mainly used in my third year basically, but now I'm using NVChad and Neovim, and never used VS personally. Maybe I should just dust off PowerShell and try that instead. Try that then, yeah. I think just maybe stick to PowerShell. But there's a few, weird things about this. Where is the other page that got opened? Here it is. This is it. Control-Shift-V. There we go. I'm gonna just save this. Feet. I write feet every time, and I know I don't need to, but habits. Okay, complete 572. Git push. VS is bolder because it encapsulates so much compiling and setup stuff for C++ and C# out of the box. That's why it was enforced in uni for me, I see. But I want to do C, C++, and C# with VS Code. I would need to research more and install stuff and compile manually versus in VS where you press a button. It's all ready to go out of the box, yeah. Makes sense. I mean, personally, I just haven't used C++ and C# all that much. Mainly just C for my programming in uni. And I think that I just picked up using the terminal, GCC dash whatever, -o or whatever, I forgot the exact compiler commands. because I would usually just make them into make files. So I'd do like make build, make clean, all that stuff from the terminal, and then just run it from there. That's using VS Code back in the day. But you know, I could have also done that now, knowing that, yeah, like I could have done this equally on a terminal, just solely in the terminal, using Valgrind, stuff like that. Okay, anyway, I think we pushed just now. Yeah. Okay, that's it for that question. Whoa. What's up here? Did this even work? Okay. Sure. So that's one Leetcode question done, and I'm going to just write a little bit there, in the sense that we can write about DFS. Solved the question myself with the hints from Leetcode as a quick guide. I didn't necessarily read into the hints all that much. Just knew that we had to use DFS. I do want to watch the video though from Neovim, just so that I understand it from that perspective, from his perspective. Let's have a watch.
Hey everyone, welcome to the question. Today let's solve the problem subtree of another tree. And this problem is actually from line 75 that we haven't really visited in quite a while, because we've solved most of the problems on this list, but you can see one of the problems, one of the few problems that we missed was subtree of another tree. So let's solve that today. By the way, this is a spreadsheet we created a long time ago, basically just tracking all 75 of the problems in the blind 75 list. You can see I've taken some of my notes on each of these problems over here, and each of the problems, or at least most of the problems, have a video solution that I created. And you can see about 16 people are actually looking at the sheet right now. I assume most of them are viewers of mine. And if you don't really care for spreadsheets, I actually did make a video playlist of each of the solutions. We have about 68 of them done. So pretty much every problem has been solved except for just a few of them, most of the hard problems at least. Okay, now let's get back to the problem. The description of the problem is pretty simple. We're given two binary trees. One is called root, so this is that entire tree, and the second tree is called subroot, and this is that second tree. And the only thing we want to know is this subroot, this tree, this entire tree, is it a subtree of this tree on the left? Is this one a subtree of this one? Now, first question, what is a subtree? So for this root tree, what's a subtree? Basically, you can start at any node in the tree and then take all of the nodes in that subtree, right? So for starting at 4, this is a subtree of the tree. Starting at 1, the node itself is a subtree. This itself is a subtree. This itself is a subtree. Even starting at the root node, this entire tree is a subtree of itself. So now the first thought that you probably have is to check if this is a subtree of this tree. let's just brute force it, right? And how would that work? Well, basically we would check, visit every single node in the root tree and then check, starting from here, does the tree match the subroot tree? So let's start at the root, right? The root of both of the trees, 3 and 4. Are the root values the same? Well, they're not, right? So that kind of automatically means that this entire tree is not equal to this tree. So then we continue, right? We check, okay, starting from here, starting from the 4, are these two trees the same? Well, we check the root values. They're both the same. They're both 4. So at this point, we're basically just comparing these trees to check if they are equal. And we can do that recursively. There's actually another Leetcode problem called same tree that I would recommend solving before this problem if you struggle with this problem. This one is also an easy problem if you want to check it out. But yeah, we can recursively compare these two subtrees. 4 and 4 are exactly the same. So now let's check the left child of both trees. 1 and 1 are both the same. Now let's check the right child. 2 and 2 are both the same. So now these subtrees, this tree is a subtree of this tree because we did find a subtree that matches this tree. So I think this is one of the problems where the solution is actually really simple, right? For every single node in this tree, let's call it S, for every single node in this tree, we compared that subtree to this entire tree, called this tree. So the way it works is basically for every position in the S tree, we have to be going through every single node in the T tree, right? So from here, let's say this is the 4, the worst tree that we compare all 3 nodes here. But of course we didn't have to do that because the root nodes weren't the same. But what I'm getting at is basically the overall time complexity for this solution of brute force is going to be S times T, and yeah, this works. So basically the size of both trees multiplied to the other. So this will get us accepted on the game. But just because understanding the solution is simple, it's actually kind of tricky. And my suggestion to you, since this is a problem, most tree problems are easiest to understand when you think of them in person. So let's try to do it. Initially, the problem is T. This subtree isn't a subtree of the entire tree here, right? This is a subtree of this tree. To determine that, the first thing we did was check the first subtree, like the root subtree that matches this tree, right? It's just 3 nodes in this case, right? And we found that no, this subtree is not the same as this tree, right? And by the way, to check this comparison, we can create a helper function to do that for us. We'll call it same tree, right? That'll be a helper function just to compare 2 trees to let us know if they're equal. But in this case, it didn't work, right? So now we have to continue the problem. And like I said, let's think of this recursively. Initially, we wanted to know, is T a subtree of this entire tree? We found that it's definitely not if we start at the root. So now let's ask the subproblem, is T a subtree of the left subtree of the root node? And when I say, is it a subtree of the left subtree over here, I'm not asking, is it the same tree? I'm asking, is it a subtree? So we're going to have 2 functions in this case. One is the helper function same tree, and another is going to be another function, I don't know what it's called. I think it's just the generic function that they give us. I think it's called
subtree. Throw it.
So basically, that's how it's going to work.
Isn't chat distracting?
It's initially going to be called
Maybe.
S and T. Is T a subtree of S? Well, we'll check, is it the same tree first, right? Okay, it's not the
Only
same
sometimes.
tree as S. So then we want to know, is it a subtree of the left subtree? So what are we going to do in that case? Well, we're going to call the same tree function. Is it the same tree as the left
That's fine.
subtree? So that's the main idea, but I think
Edge cases.
100%
Let's have a look.
until we actually jump into the code. So let's do that in a moment. But as with most recursive problems, we definitely don't want to forget about the important edge cases when we are comparing the trees. So first thing, let's start with the helper function. What would happen if both trees were null? In that case, are they the same tree if they're both null? And yeah, if both trees are null, yes, they are the same. What about if 2 trees, like this one and this one, had the same initial values, right? Like the first 3 values we can see are the same, but what if one of the trees had an extra node here, right? Then is this tree the same as this one? Of course not, right? So we'll have to keep track of that when we do our is same tree function. Now what about the is subtree recursive function? If both of these trees are null, is our is subtree going to return true? Is t a null subtree, a subtree of another null tree? Well, that's going to depend on our same tree helper function, and it's going to return true, so yes, a null subtree is a subtree of another null subtree. But the more interesting edge case is, what if S was null, right?
S is null.
But T is non-empty. In that case, is T a subtree of this one? Nope, it's not, right? Because this tree cannot be found anywhere in the S tree. But what if the opposite was true? What if T was an empty
Then yes.
tree? Then is an empty tree a null tree? Is it a subtree of a non-empty tree?
Yes.
And in this case, the answer is yes. And the main intuition I use is basically, if we had a null tree here, we could just go to one of the children of, one of the leaf children of the other tree, and technically these have a null subtree because they do have a null child. So that's kind of the intuition I use. But that might be a good clarification question to ask in a real interview. But in Leetcode's case, I think they do want that to be true. So those are the main topics that I wanted to go over. So now let's actually jump into the code and see how we can implement the solution. Okay, so now let's get into the code, and like I said, we are going to define one more function, a helper function.
Same tree. Alright, I'm good. I don't need to see the rest of that, but we're good there. We will do one of the things that I wanted to do for the scheduler app. I gotta educate myself a little more about certain topics, i.e. grids. So that is what I'm gonna do. I'm gonna just keep this here on the side and open up foundations. I do have this. Ooh, why is that still like rolling? Is that just a bug? Yeah. So part of my learning is to do a lot of these and understand grids. I'm going to understand grids before I do any of these first. So I'm going to do one lesson of this from the Odin Project. And I'm going to have to go back on this to the foundations in alignment. Which I can't mark complete yet because there's quite a bit still left missing in my understanding. So I'm going to have to move all of this here. And we have intermediate HTML and CSS for the grid aspect. So we're going to go into grid and just read up on this. Okay, this is one thing that I'll read up on, right? Before I chill for a bit and do some study. Actual study. So my thinking, just got a few things open. Got a few issues as well that I could get onto. Just remember I'm going to change the icon, definitely. I feel like doing that now, but because I feel like it's a quick fix. Nah, it'll be a waste of time. It'll be a waste of time to do it right now. So we'll learn about this. Ooh, funny step BK. Hey, can you tell what CS books you use for reference to kind of revise your college lectures? To be honest, there aren't many CS books that I particularly follow. It's more like web sites, web pages. Like information from W3 schools is good if you want to revise DSA. But if you're talking specifically about the CS lectures, the college lectures I'm doing right now, we're only getting started for AI, and those books are actually way more detailed, to the point where there's so much detail that I don't want to read them. So that's a problem that I'm facing, to be honest. But CS books, in terms of DSA, I don't have any. Just go to the web. That's basically what my suggestion is. W3 schools, any of the other ones online, when you search up a certain DSA problem. But that's only data structures and algorithms. I guess another resource that I have, that I know of, is a YouTuber named Internet of Bugs. He does these book club videos talking about certain software books as well. So, you know, he's got lots of books in his background, and he's a bit of a he gets a little bit tilt when talking about software engineering, but he's a good resource. I've seen a lot of his videos, and you know, he goes through some of these book club videos, which I would recommend you watch, and just to understand his perspective on some of these books, and then maybe you'll read those books yourself, you know. That's my thinking. Okay, intro to grid. Over the next few lessons, we'll cover CSS grid and make page layouts much easier. First, we'll take a quick look back at Flexbox, and then learn about grid. The following lessons will show you how to create a grid, position grid items, and use some advanced properties. Then we'll take a deeper look between Flexbox and grid. Ultimately, we are working towards building a dashboard project using grid. This section contains a general overview. Compare the basics between Flexbox and grid. Describe a situation for using grid over Flexbox. A look back at Flex. In the Foundations course, you learned a lot about the Flexbox. If you've been using flexes here and along the way, this section will be a quick refresher before we'll get into grid. If you're completely lost on Flex, then it might be helpful to go back through the Flex lesson again to get up to speed. Fair enough. Okay. Funny step BK says, actually my problem is that I can't really find resources for C and C++ and computer architecture core level stuff. But there are not much good ones out there, and if there are, they're pretty old. But thanks for your help. Not gonna disturb more. Okay. That's okay. That's okay for disturbing, man. It's all good. But yeah, for C and C++, yeah, I would say, if you find one, let me know as well. You could let me know if you want, but if you join the Discord, that is, because I have a Discord in the description you can just go to. If you do find one, I'd be happy. I'd be curious to know what you chose at the end of the day. All right, cheers. The flex lesson covered position items along two flex axes main and cross. How do you set the flex alignment? You can also learn how to make your flex items grow, shrink, and change their size. This is the real beauty of Flexbox, as items can, flex to stretch out or shrink down. Remember, you can line up a nice row of flex items like this. Indeed. Or a column like this. Indeed. For one-dimensional layouts, Flex offers a convenient tool without having to rely on floats or CSS hacks to align your items properly. For two-dimensional layouts, you learn a little bit about Flex Wrap, which allows you to take your Flex items and wrap them to the next line. This can be done with either a row that wraps to another row, or a column that wraps to another column. Remember how much fun you had to solve the card layouts in this exercise? Sure. We know that was a frustrating one, but part of the point. While Flexbox allows you to build a layout of rows and columns together, it isn't always easy. By setting up a two-dimensional layout of cards would be much easier using CSS Grid. So display grid, grid template columns, grid rows, gap of 32 pixels, background color, peach buff, border 1 pixel, solid black. So what is grid? Although grid is a new module to CSS, this layout tool has long been in development. Fun fact, CSS co-creator Dr. Bert Boss, no relation to Wes Boss, started working on the layout model in 1996. This idea was inspired by the use of grid-like layouts in other forms of media like newspapers and magazines. After years of thorough demonstrations and development, CSS Grid was finally introduced to all major browsers in 2017. That is not long ago. As shown above, Grid is often praised for easy placement of items in a two-dimensional layout, but a grid can be used for one-dimensional layouts too. One advantage for developers is if they start off with one row of items, they can add additional rows later. You will notice a lot of similarities between Flex and Grid. Both use parent containers with child items. They have similar properties named for align and positioning, but you also come across a lot of differences between the two and opinions on how each module should be used. For example, if you've been struggling to get your flex items to all match evenly in size. Grid can make this type of layout much easier. When reviewing older resources, keep in mind that differences between Flex and Grid can also change as these modules get updated. One of the big highlights for CSS Grid was the use of the gap property. which we will cover in the next lesson. This used to only be available to Grid, but is now supported with Flex 2. While some people thought CSS Grid was here to replace Flexbox, you will learn by the end of these lessons that Grid is just another tool for the bag. In fact, not only do each of these modules have their own use cases, but you will also find it helpful to pair Flexbox and Grid together. But we'll be covering all of that in the concluding lesson. First, you will learn how to actually make a grid. How can you use Flexbox to make two-dimensional layout? You can do a flex wrap. So what was CSS Grid? Why was CSS Grid introduced? It was to follow like a newspaper layout. And which CSS layout module would you use to easily make equal-sized items in a container? Grid. This section contains helpful links. Which Flexbox vs CSS Grid, which is better for visual representation of use cases for Flexbox versus CSS Grid. Read CSS Tricks' quick take on the difference between Flex and Grid. Check out the story of CSS Grid. Let's have a look at each of these. Good, it's not a long video.
One of the biggest questions people ask when they first learn about CSS Grid is, hey, does this replace Flexbox? Should I use Grid instead of Flexbox? No, that's not really how things are going to work. So Grid has been invented to do things that Flexbox couldn't do, and Flexbox is still a great tool for us to use to do things that Grid can't do. And we're also going to use a lot of the other parts of CSS that we've used for layout for a long time. Floats, for example, there'll be plenty of times to use a float. And flow, the way the web pages get laid out, the way it's always been before CSS actually was invented, the way content flows down the page in a block direction or an inline direction, these are all parts of a larger picture that we'll want to understand and put Grid into that situation. We'll use Grid on certain parts of the page and not on other parts of the page. It's not like the tools that we've been using, say, Bootstrap or Foundation or 960 Grid back in the day. It doesn't handle layout for the whole page. It handles layout for a particular container, one container on the page, and the items that are a direct child of that container. So you're going to mix Grid with other things. You'll mix Grid with Flexbox. You'll mix Grid with a basic flow. You'll mix Grid with floats, with other kinds of things. So why do you want to use Flexbox? Why do you want to use CSS Grid? Which one should you use when? Flexbox is really great when you want to line things up in one direction. Maybe you could think of it as a whole bunch of boxes that are in an infinitely long line. Oh, but it's not infinitely long. It's actually a limited amount of space, so it happens to wrap or it doesn't wrap. Whether it wraps or not, the calculations that are being made are all happening one line at a time. The browser only ever thinks about things in one dimension at a time. It doesn't have any way to know if you end up with several different rows. It doesn't calculate information across those rows, or if you're going the other direction. It will calculate them in one direction and not in the other direction. Grid has the ability to line things up in two directions, and in fact Grid always lines things up in two directions. You can't get it to kind of stagger things. It thinks about rows and columns at the same time, and it's going to want to make adjustments to your code based
The hands.
on what's going on in both of those directions at the same time. So here's a diagram of a layout that you would do with Grid, where things are actually lining up in both directions. And here's a diagram of how things might work out in Flexbox, where the calculations are being done in each row.
Sure.
one at a time,
Yeah,
with
yeah,
no
yeah.
regard to the other rows. And you
This
can
makes
see that
sense.
the rules don't actually line up. Perhaps it's dependent on the size of the content or the size of the amount of stuff that's on the page. Here's a diagram that really kind of shows you what grid is good at and what Flexbox is good at. There are some situations where Flexbox or grid could be used where they basically do the same thing. One thing, though, that grid can do that Flexbox cannot do is intentionally overlap items. So if you're in a situation where maybe either you or you want to overlap items, then that's going to be a situation you definitely want to use grid in.
I want to use grid for that.
Here's an example where we've got images that are content images, not background.
I need grid for that.
A sentence for each one, and a little background color on each of those sentences. The sentences are different lengths, so we don't want to use some sort of absolute positioning or something that's not going to work for different amounts of content. We're going to use grid for this, but we're using grid. We could use Flexbox if there was no overlap, but because there's overlap, we want to use grid in this situation. So get to know grid, get to know Flexbox, kind of know what each one is best at, and then use whichever one is best. It depends on which one has the superpowers that you need at that moment.
That's true. Hey, mad. Absolutely true. Okay, what's the difference between Flexbox and grid? Similarities between Flexbox and grid, starting with the fact that they are used for layout and much more powerful than any layout technique that came before them. They are stretch and shrink. They can center things. They can reorder things. They can align things. They're pretty layout situations in which you could use either one to do what we need to do, and plenty of situations where one is more well suited than the other. Let's focus on the differences rather than the similarities. Flex can optionally wrap. Grid can also optionally wrap if we allow autofilling, to the sense that the items can fill a row and move to the next row, or replace themselves, but as they do, they will fall along the same grid lines all the other elements do. They will wrap down onto another row when the flex item fills a row, when the lines up to the next row. It's independent of what happens to the first row. Allow for a masonry-like look. Masonry. Sure. Grid is better at overlapping. Grid is sturdier with the flexing of flexboxes. Sometimes its strength. The flex item's size gets rather complicated. It's a combination of width, min width, max width, flex basis, flex grow, and flex shrink, not to mention the content inside and things like white spaces, as well as the other items in the same row. Grid has interesting space occupying features like fraction units and the ability for content to break grids, though generally speaking we're setting up grid lines and placing items within them that plop right into place. Flex can push things away. It's rather a unique feature of Flexbox that you can, for example, put margin right auto on an element. If there's room, that element will push everything else as far away as it can. That's fine. Story of CSS Grid. Its creators. Mad. Creating a grid. Here we go. Positioning grid elements, advanced grid properties using Flexbox and grid. I will say maybe I will do creating a grid here, because I want to build something like ASAP. Okay, hold on. I'm gonna take a break for like less than 5 minutes. BRB. Okay. Now that you know what CSS grid layout is, you'll learn how to create your own grid. This lesson will cover making a grid container, adding columns and rows, the explicit and implicit concept behind grid, and how to space out grid gaps. Okay, this section contains a general overview. Make a grid container, define grid tracks, explain the difference between an implicit and explicit grid, set gaps between grid cells. Grow, shrink, flex basis. Grows and it shrinks, and the basis position. Okay, so setting up a grid. The example, the parent element marked container becomes a grid container, and each of the child elements below it automatically become grid items. If we had another element as a child under one of these child elements, it would not be a grid item. An example below the paragraph element is not a grid item. If you want. The whole thing is a grid item. Grid item, grid item, grid item. HTML. HTML. Oh, where does it say grid though? Does it ever become grid? If we're talking about, say I've clicked this, right? And I click this. There we go, that's a grid container. Example, the parent element marked class container becomes a grid. Lines and tracks in grid, oh my. As you're coding along with our example, right? You'll notice it doesn't look very gridish yet. A lot of resources on CSS Grid like to show you boxes and outlined grid tables right from the start. But if your grid container and grid items don't have any borders, you won't actually see these lines on the page. So don't worry, they're still there. If you inspect these elements on a web page using DevTools, you'll notice grid badges on the grid elements in the code. The layout options of the DevTools allows you to select an overlay that can show these invisible lines, the tracks and areas of the grids. You read about using a browser's DevTools in the assignment below, and learn more about lines, tracks, and areas in the next lesson. Columns and rows. Now that we have our grid container with several grid items all set up, it's time to specify our columns and rows. This will define the grid track, the space between lines on a grid. So we could set a column track to give us space between our columns and a row track to give us space between our rows. We'll get into the specifics of tracks and lines in the next lesson, but now let's just make some columns and rows. Grid template rows and columns. In the upcoming lessons, you will learn more about defining with percentages and fractional units. Going back to our grid container from above, let's define 2 columns and 2 rows. To place our 4 grid items. Wow, okay, sure. If we want to add columns or rows to our grid, we can define these values to make another track. Let's say we want to add a 3rd column to our example. Sure. And grid template rows, grid calls, I see, grid rows, how do you define a grid then? Display grid. Let's just define grid. Whoops. Inline grid. Oh my god. Why would this ever be useful? I gotta think about it a little better. CSS Grid also includes a shorthand property for defining rows and columns. In our previous example, we can replace the properties of the grid. Oh wait, can I add more here? Whoops, whoops. Copy, paste, paste. CSS Grid also includes a shorthand property for defining rows and columns. In our previous example, we can replace the property of a grid template rows and grid template columns with a shorthand grid template property. I see. Here we define our rows and columns all at once. For this property, rows are defined before the slash and columns are defined after the slash. I guess it doesn't matter with Tailwind. keep the same column and row values but use the shorthand property instead. So what if you had all of this but only with one row and one column? Grid container, grid item, and everything else is a grid item without the specification. Interesting. Columns and rows don't have to share all the same values either. Let's change the property values of our columns so that the first column is 5 times as wide as the other. Sure. Explicit versus implicit grid. Let's go back to our original of a 2x2 layout with the 4 grid items. What happens if we add a 5th item without changing grid template and grid row properties? You'll notice our 5th item was placed in the grid and it's been slotted into a 3rd row we did not define. This is because our implicit grid concept and how CSS Grid is able to automatically place grid items when we haven't explicitly defined the layout for them. When we use the grid template columns and grid template rows properties, we are explicitly defining grid tracks to lay out our grid items, but when the grids need more tracks for extra content, it will implicitly define new grid tracks. Additionally, the size values estimated from our grid template columns or grid template rows properties are not carried over into these implicit grid tracks. But we can define values for the implicit grid tracks. We can set the implicit grid track size using grid order rows and grid order columns. In this way, we can ensure any new tracks the implicit grid makes for extra content are set at values that we define. Let's say we want any new rows to say the same value as our implicit row track size. Valid. By default, CSS Grid will add additional content. Hold on. I'm going to go back. Oh yeah, so how many things have I learned? Aspect ratio, container columns, break after, break before, I don't know. Boxes. I'm guessing that's just box model. Floats, is this? It's box border. Sure. Floats. To the right of the container. Floating elements. Sure. Right. Inline. Or not inline. Sure. Clear. Never needed. Object fit. Object position. Interesting. Z index. Visibility. Position. Overscroll behavior. Overflow. Object position. Where's the flex? The layout of flex. It's not here. I guess they're in their own section. Anyway, grid auto flow. Grid auto columns and grid auto rows. The gap between grid rows and columns is known as the gutter or alley. Gap sizes can be adjusted separately for rows and columns using the column gap and row gap properties. Furthermore, we can use a shorthand property called gap to set both of them. Before adding our grid gap properties, let's make things a little easier to see without relying on developer tools. We'll go ahead and add a border around our grid items, so we can get a better sense of the placement around the others. Contain a div, yeah, right. Next, we'll use a slight grid column gap to space out our two columns a bit. Right, first we'll add a lot of gap rows to highlight the difference. You can also try playing with the shorthand gap to set both row gap and column gap. In the above code pen. Now that you've made a grid, you can start to see how easy it is to control the layout of the elements with CSS Grid. You may also realize how CSS Grid can solve common layout problems. In the next couple of lessons, we'll cover positioning elements and advanced grid attributes. Positioning elements. Okay, sure. But first, check out the links below that cover making the basics of grid in more detail. Darn, so many. I want to just read. Hello, Kizatsu. Hope Odin's going well. Yeah. It's alright, it's alright. It's alright, I suppose. Watch this short video on implicit explicit tracks. Go through the develop tools on expecting CSS Grid and Chrome Dev Tools. I think I know how to do that anyway. Knowledge check. The following are okay. How does a CSS element become a grid item? It has to be contained in a grid container. What is the space between lines on the grid? I was gonna say alley and an alley, but I won't say that because it's not an alley. How do you set gutters? So how do you set gutters, also known as alleys, in the grid? By defining a gap, column gap or row gap. Describe what happens when you have more content than defined tracks. The implicit grid will come into effect, which you can set with the auto tags or with grid auto rows, I think, something like that. Grid auto rows, grid auto columns, valid. How could you change the size of those undefined tracks? Yeah, grid order. Everything I said. The MD and basic concepts of grid layout reviews many of the basics, introduces some additional concepts. Which is saw a video of grid terminology from Peter Sumerhoff. Holy, you're telling me I have to read all of this? 1, 2, and 3. See, where's 1, 2, and 3? Okay. CSS tricks. Almanac. Interesting. Okay. Introduction, basics, important terminology. Introduction. CSS grid. Okay, I'm gonna have to eat lunch in a moment. Important grid terminology. Grid container, grid item. Grid line, grid cell. Grid track. Grid area. Valid. Okay, fair enough. Implicit versus explicit tracks. Okay, we'll get to it. CSS layouts. Ooh, wait. Okay, we'll understand all this through watching that video, I would reckon, and we're gonna have to. Alright, be right back. I'm gonna eat some lunch. So, gonna give myself. Yeah, I'll put some lo-fi music on. If I can drag this. Alright, I'll be back.
This video is going to be one of those fundamental understandings of CSS Grid, and it's something that's going to keep coming up. So let's make sure that we absolutely nail this before we move on. And that is understanding the implicit grid, implicit tracks, and explicit tracks, and the explicit grid, and how we can sort of use them together in order to make a really flexible and fluid looking website. So open up O5 and the starter file that we have there. I've got 4 items here, and I've displayed grid it. Let's go ahead and turn on our dev tools here so we can see how it's looking. And I'm going to make my tracks black. Good. Now, let's go ahead and make sort of a 2x2 grid that we have there. First, we'll put some gap on there, 20px. Good. And then we'll add some columns. And let's do 200 pixels and 400 pixels. Now we've got a grid with 2 columns in it, and then we have 2 rows. So this is the difference between the explicit and the implicit. I have explicitly defined what the columns will be, and then I have not defined what the rows will be. So those are what are called implicit. So if you do not create them, they are called implicit, meaning that the browser says, oh, okay, well, you've made 2 columns. Great, I can put 1 and 2 there, but now I've got these extra elements left. What do I do with them, right? Like, you can't just throw them out. They need to go somewhere. So what it will do is it says, okay, well, I have no more columns to put them in, so I might as well start to wrap onto the second line, and that will then create a row. So even though we did not define any rows here, they have been implicitly created. So if we then zoom in to see everything that we have, you'll see that the solid line means that that is where our explicit grid has been started. And then the dotted lines means that is where the explicit columns have been created. And then the dotted horizontal lines are a little bit lighter, and that means that they are implicitly created. Watch how that changes if we just, let's dupe this over and change it over to rows as well. And now you'll notice that if we zoom in, first of all, they are much bigger because we have defined what the sizes of those rows will be. But now if we zoom in, you'll notice that the horizontal lines that we have in DevTools here are now solid and dashed and not opaque and dotted. And that is because we have explicitly defined what they will look like. If we scroll down here, you'll see also we have a solid line, and that means that is where the explicit grid ends. So solid line is where the explicit grid starts and stops. So you can see that it's the column starts here and the columns end here, and then up here the columns start here, or sorry, the rows start here and the rows end here. So this is 100% explicit. Let's make these a little bit smaller in terms of rows. So maybe we'll do 50px and 100. Now here's the big question. What happens if I now add a 5th and a 6th item to this? Whoa, what just happened there? Well, we only told it that we want 2 columns, which is fine. So 1, 2. But then we only sized 2 of the rows. However, we have 6 items. So what's happening is that CSS Grid is going to say, well, okay, I'm done with the explicit grid. See how this solid line ends right here, but I've got extra items. So it's going to then create a new row for us. And that is referred to as a what? An implicit row. Good. So we've gone over these. We've got our gap, we've got our grid template columns, and our grid template rows. We've done those a bunch of times. Now the question is, how do I size these implicitly created ones, right? We can go ahead and size the values for the explicit ones, no problem. But the implicit ones will look a little bit something like this. So we say grid auto rows, and the grid auto rows will define how big the rows are for when they have been added. So if I were to then add, let's do something ridiculous like 500px. Now you'll see that any extra implicitly created rows are now going to be 500 pixels high. So if I were to dupe these over into 7 and 8, you'll see that 5, 6, 7, 8, all of those implicitly created rows are going to be 500 pixels high. You might be thinking, okay, well, could I do something like this? 100px, 500px. And if we go and inspect it, you go on 5 and 6. Let's look at the rules here. Let's look at our container. You'll notice that it's actually crossed out, and that's actually currently an open issue at the time of recording in Firefox, is that in Firefox, you are not able to define the size of multiple implicit rows. And if we were to open that up in Chrome, you'll see that it actually does work. So you should be able to do it. It should be fixed fairly soon. But at the time of recording, you're only able to pass one value for the implicit rows. Okay, we also have grid auto columns. And let's say that would be 100px and give that a save. Now that didn't do anything. And that's like, how do you get extra columns? So by default, what will happen is you define your columns, and then any extra elements will automatically be turned into rows. But that's where the next video comes in. We're going to be talking about something called grid auto flow. And that is instead of automatically giving us rows, we're going to automatically give us more columns. So I'll see you in the next video.
In this episode, I would like to talk about debugging CSS Grid with DevTools. In my previous video, we talked about debugging CSS Flexbox. Grid debugging tools are similar, but with more details in it. Let's say you have a grid container defined and want to create a layout like this, with a fixed height header, a slim sidebar, and a big content area. Let's start with enabling the grid badge next to the container. This way, you can visualize the grid layout better on the page itself. Another thing I would do here is extending the grid lines in the layout pane. I find the extended lines very helpful to inspect. Another thing I would do here is extending the grid lines in the layout pane. I find the extended lines very helpful to inspect the grid alignment. Let's define the grid structure. We will have 2 rows with 100 pixels and 1 FR each. 1 FR means a fractional unit of the available space. Next, we define 2 columns with 1 FR and 2 FR each. The section placement is not quite right now. Let's fix that with the help of the line numbers on screen. The line numbers on the side are the row numbers. We can refer to a particular row with either numbers. For example, we can place the header in row 1, or we can refer to it as row -3 as well. We also want to span the header across the whole line. The top and bottom line numbers refer to the columns. In our case, we want to span the column through line 1 to line 3. -3 to -1 works too. Now, our layout is looking good. The declaration just now is fine, but in some cases, you might label your line instead of using line numbers because numbers can be confusing sometimes, especially if you have a lot of grid items. DevTools can help you with that. Here, I will label the column lines as start, middle, and end. In the layout pane, I can choose to show line names instead of numbers. Then, in the header, I can adjust the column to span from start to end instead of using the number. Isn't that nice? Apart from that, some people might label the grid by area instead of line. You can use DevTools to visualize that as well. In the grid, we can label the grid template areas by top and side main. Then, in the layout pane, we can enable the Show Area Name settings. With the area name shown on the screen, it is easier for us to work with our grid items. In the header, we can disable the row and column styles and replace it with Grid Area Top instead. Another nice debugging settings is to show the track sizes of the grid. In the layout pane, enable the Show Track Sizes option. The size labels are added to the overlay. The labels not only show the sizes we define in the Styles pane, but the actual size as well. The labels are updated in real time as we change the grid size. The last feature I want to mention here is the Grid Editor. It can help us to adjust the grid layout without memorizing the syntax. Say we want to align our grid items to center, you can click on the Grid Editor button in the Styles pane, then select Align Item Center and Justify Item Center to center the items. I like this editor because it shows me a nice overview of all the options visually. Alright, to learn more about grid in general, go to this web.dev link on the screen. And to learn more about debugging grid with DevTools, go to goo.girl/devtools-grid. That's all. See you for the next DevTools tips. Ciao!
Now in this lecture, I'm going to go through all the terminology that's required in order to know what CSS grids are all about and to follow any explanations on the specification. Don't worry, it's not too much terminology, but it's just required in order to be able to really talk about CSS grids. So first of all, there are grid lines. A grid line can be either a horizontal line like here, or it can be a vertical line, therefore separating all the columns in the grid. So the grid lines are basically all the lines that you would end up drawing if you were to draw your grid on a piece of paper. And now with the grid lines defined, we can also define what a grid track is, the area between two grid lines. So effectively, a grid track is going to be one or more rows or columns. So in this case here, you can see that the grid track here is just a row in the grid. It might also be a column, it could also be two rows, but it's just the area between two grid lines. So similarly, this might also be a column here if we're talking about a vertical grid track. And so then next we also have grid cells, which are areas separated by 4, and they are the smallest unit you have in a grid. So essentially it's just the same thing as you would normally refer to when you're talking about a grid cell. So the same thing as a grid cell in Excel, for instance. Now, apart from the grid cell, there's also the more general grid area. So this is also part of the grid that's defined by 4 grid lines that surround it, and it can be used later on to arrange elements on the grid. So this is going to be a very powerful tool, and you can see this as a generalization of a grid cell, which is also a grid area, but the smallest grid area you can have, so just one cell. Now lastly, all we're going to have to talk about is a grid container and grid items. So the grid container is just going to be the whole grid that contains all the grid cells, and a grid item can be any element that you place inside the grid. Like for instance here we have one grid item that spans just one cell, and similarly you can also have grid items spanning multiple rows or columns, like here for instance spanning 2 columns. So it's going to be a very flexible tool to lay out your elements on the grid in whatever way you like. And now with this, you also already have all the terminology you need in order to understand any blog articles or anything I talk about in this course and anything that's related to CSS grids. So with this, we're now ready to move on and really dive into how to use CSS grids.
Sky Caffeine says hello. Hello to you too, Sky Caffeine. Sky Caffeine, do you have a Discord voice where someone come and study with you? Or you do this only in live? That's a good alternative. It's a good consideration. I've never thought about that. I mean, I have a Discord that you can join. I've put it in the description below. Maybe I can do that in future, possibly. But it could be iffy because anyone can join, and then it could get more distracting. But yeah, it could be a possibility in future. But yeah. That would be awesome for me. I'm studying React and learning Neovim anyway. I feel guilty making you move this giant microphone every time. No, don't worry, man. It's my choice. It's my choice to move this thing around. I actually like just moving this around, so it's good. But yeah, okay. You know, you're learning the same stuff pretty much. Don't feel bad also. I only keep it moved out of the way when you know, I know there's other people behind me. I don't want to speak too loudly or too much. But now they're gone. If they come back, they'll expect me to go silent for a bit as well. I need to make this into a grid. Is there going to be ever one column and one row? A grid item. Let me search, let me look back here. Grid. It's just a div inside, so it's fine as it is like this. What do I need to do? Yeah, open up terminal, front end. Just run Docker. Before I continue, open up Docker. npm run dev. Alright. So open that up. Scheduler. Tasks. Ooh. That is not the app yet, because this is just not the app. Just gotta open it up elsewhere. Just put it here. Here we go. Okay. Gotta just look at these closer. Grid item. Inside a grid. Inside that grid, we shall specify a grid call 1, grid row 1, so sure. Unfortunate that this is, just don't like that being a little bit weird. Maybe I need to move all these classes out. MR2 is the biggest culprit. Alright, so we moved MR2. MR2 Yikes, that's not right, is it? It's not looking okay here, at least. Let me see. Yeah, problem. you need like an MR2 above here probably. Does that work? Not really. Oh, but I guess I know why, right? H5 W5. That fixes it, but just gotta remove this now. That works, but now the grid calls, we're gonna have to add let's have a look. Overlaying. Since both items are instructed to occupy the top left cell of the grid, they overlap. Column start, grid row start, grid row start. Maybe I need to go to Tailwind just to double check. Grid row start, Tailwind. Row span auto, row span 1, row span 4, row start, grid row start. Oof. I believe grid positioning, I will learn it in the next section of the Odin Project, which was going to be coming up. Hello Zahaib Hassan, welcome back. In the case if you need some space gap is the way. Oh yeah, anyway, I don't understand why are you using grid here? So I'm using grid specifically for the circular button. Right, so for this circular button, I want to add an overlay of inside that button having a tick. So I want to have a tick in here so that when you click on it, it'll show up a tick, or even when you hover. So bro, how are you focused for so long? I mean, I just came back from lunch not long ago, so I got my break. And this is technically the fun part, so this stuff is fun for me. I gotta do some study later on, after this, after I figure out this, just to show the tick inside a grid. So, alignment, creating a grid. I've done all this now. So positioning grid elements, this is what I want. Basically, at least. Grid start, grid end. Grid area. You specify start and end. Grid area living room, if you go by that. line-based placement with CSS Grid. What kind of values do we give the grid column start and column end properties, like integers? Is that what you're talking about? Integers, maybe? Okay. Explain the difference between a track and a line. Smallest unit of a grid. A cell. That's fine. Which property can we use to combine all the start and end values for a grid item? Grid area. And which grid container property can map out a visual structure of grid items? Are you trying to do a custom checkbox? Yeah, basically. That's what I'm trying to do. Okay, let's read a bit more about these, I suppose. Describe the difference between track lines and cells. Position items by defining their start and end lines. Use shorthand notation. Before we dive straight into positioning, let's establish some terminology to better understand the difference of different parts of a grid. In the previous lesson, you learned that when you define a grid using grid template, you define the tracks the grid will have. You'll think of a track that is a single row or column on a grid. To give an example, we want to create a 3x3 grid with 100 pixels and 100 pixel columns. We need to define 3 horizontal tracks with a height of 100 pixels and 3 vertical tracks with a width of 100 pixels. 100, 100, 100, 100, 100, 100. That'll be 9 by 9, yeah, 3x3. So Sure. You will notice 2 CSS lines have been commented out in the code pen. Uncomment them. Uncomment the property to get the grid track between the 3rd and 4th column grid lines. Yeah, sure. 3, so 0, well 1, 2, 3, 4. So 3rd, 4th. Assuming that is how we think about it, you know, let me have just a quick check of this whole thing. Container with a grid 3rd and 4th, between the 3rd and 4th grid lines. Lines, when we create grid tracks, grid lines are created implicitly. This is important. Grid lines are only created after our grid tracks have been defined. We cannot explicitly create grid lines. Every track has a start line and an end line. The lines are numbered from left to right and top to bottom, starting at 1. So a 3x3 grid above has vertical lines for columns ranging from 1 to 4 and horizontal lines for rows ranging from 1 to 4. Grid lines are what we use to position grid items. We'll get that in a minute, but first let's take a deeper look at the grid lines using our developer tools. If you have up developer tools in Chrome, you can navigate to the layout pane and find the grid overlay display settings. Make sure that show line numbers is enabled. Display line numbers. Select the correct element from the grid. This might be div container if you're inspecting our code embed. You should now see an overlay of the grid lines. Notice that developer tools also show negative lines opposite from the positive lines. You do not have to worry about the negative lines for now, but know that this gives your gives you another option to use when positioning the grid items. Let's have a look. 4, 1, 2, 3, 4. I'm guessing the bottom has 4, 3, 2, 1. Fair enough. Yeah, it makes sense. Lines. When we create grid tracks, grid lines are created implicitly. Oh, am I reading the same thing? Yes. Cells. The space in a grid shared by a single row track and a single column track is called a grid cell. Right, so the space in a grid shared by a single row track and a single column track is called a grid cell. You can think of a grid cell like a cell in a spreadsheet, a space defined by a row column coordinate. By default, each child element of a grid container will occupy one cell. Each child element will only occupy one cell. In the example above, we have 9 cells. Each one with automatically positioned child element inside. The element marked with the letter A is occupying cells that lie in row track 1, between row grid lines 1 and 2, and column track 1, between column grid lines 1 and 2. The items marked with the letter H is a cell at a row track 3 between row lines 3 and 4 and column track 2 between grid lines 2 and 3. But what happens if we wanted to change the order of our grid items? We wanted items to occupy more than one cell. Positioning. To get a feel of how items can be positioned, we'll create a mock floor plan for an apartment. Let's start with the total area of an apartment, the grid container, divided into 5x5 grid. To make this example a little clearer, we'll use a background color to distinguish our container space. So there's a 5x5. Note that we also do display inline grid here so that our container does not stretch to take up space the way a block level box would. This will just help us better visualize the space. As it stands, this is a pretty sad unit. To make it less of an empty box and more of a home, we're going to add some items to our grid container that will represent different rooms. Call start 1, call start end. Grid start 1. So row start 1, row end 3. We positioned this to use grid column start and grid column end, then property. You also notice how commenting our property values of this item, uncomment this to see rooms. These properties allow us to use existing grid lines to tell how many rows and columns each line should span across. Take a minute to play around with the property values here. If the line numbers are confusing, inspect the container using your DevTools to show the grid overlay. Next, we'll need our space more efficiently. We will make the rest of the room span multiple grid cells and fill out the rest of this apartment. Sure. Why not make the bathroom the exact same as the closet? You know what I mean? So 1, 2, 3, 6. Let's just change that to 1, 2, 3, 6. Oh well, the 6 is already there. I wish I could zoom in here, but that's overlaid. So between bathroom and closet. So that's basically how you do it then. Now with blueprints, one problem with our floor plan is the bathroom and kitchen are opposite ends of the apartment. We would save money with the planning by placing these two rooms back to back. Take a minute. So you can change the starting and end positions. And grid area. Okay. Let me just stick to grid area. So now I'm on grid area, but we need to go start and end, right? Grid column start, grid row end, grid rows, so row start, row end. Okay. I'm guessing that's how it works. These look arguably a little bigger than what I had before. Onto yeah. This is gonna be iffy. But you're right, I could do a gap. So I don't need this, potentially. Just do a gap. Between the two items here. Let's see, tailwind gap. MR2, how much is MR2? MX MR-2, 8 pixels. So we're looking for 8 pixels. A pixel gap. So gap 2 should do it. We only need it on one side though, so I'm expecting it to not look good. Self start. Don't think so. It's got gap 2, but let me see. Yeah, gap 2 is fine. It's not fine here though. I put it as flex none. Does this have to be flex none here? Right. Transition colors, sure. I think that looks fine. But now we need the tick symbol, which looks like that. And when I go back here, they're gridded up like this. If I check out that grid, yeah, it's basically overflown because it's only one spot. And why does that not look like it's fully flush? Doesn't necessarily look like it's fully flush, you know what I mean? Alright, that's fine. So I can put it directly on the value itself. Row start 1, row end 1, column start, call start, call end 1. Sure, and then these same attributes need to go here. I'm gonna put it at the front. Maybe I'll put it here. Row start 1, row end 1, call start 1, call end 1. Yeah. Nice. Kind of. It's half good. It's kind of good. Just gonna make it smaller. This is a check mark. Should be in its own div still, right? Because if we put it in its own div, I should be able to center this somehow. Align items. Yeah. Justify center, align items. No. Why is this badly centered? (16 and 24). Why is it a 16 by 24? Whereas this circle is a 20 by 20. 16 by 24. Is that just what it is by default? By default, so this is a 20 by 20. The tick mark is a 24 by 24. 16 by 16. By 20, so 16 by 16. Maybe I just do 5. I mean, it's all right. Definitely could be better because that's an overlap right there. Maybe make it smaller. If I did make it smaller, that's also part of the problem, no? No, that's way too small. But why does it even also align upwards like that? Flex item. Flex container. Align items. Justify center. The justify center works. So if I got rid of justify center here. Now what if I got rid of align items? Do I need align self? Self center. It's item center. Thank you, thank you, thank you. Thank goodness that I have Sky Caffeine here. I really just went align items thinking it was CSS. Oh, that solves my problems, and that makes sense. Now let me make this slightly smaller. This will be too small. It's not too bad, but it's a little thin. Is there a 3.5? I'm just gonna take a stab guess. There is a 3.5. That kind of looks okay. It's just a little thin. Width, height. Okay, sure. Marginal difference, but Todoist, right? Take inspiration. That's a tick that is similar in size to the actual thickness of the ring. And it's also slightly less protruded. So I'm kind of thinking like it's maybe a little bit too thick up here. I can change the stroke width. Sure, you can change the size. Maybe I do make it smaller and then just increase the stroke width. That looks okay. Like that actually does not look too bad. And then I want to animate this as well, right? But also this tick only comes up when you're hovering. So yeah. I'm gonna just have to duplicate a little bit of code, but I'm gonna have to put this also in its own thing. In its own component, sorry. Doesn't actually change anything for me because it's BG. Arguably, I think I messed something up. Or something's just not working the way I think it is. I'm just not going to worry about it. Same with these. I'm just missing... These aren't very noticeable, so I'm just going to remove them. Just keep it simple. I gotta try. Just changing this to a check. Stroke width 4. Oh my god. H4, H3, W3. No, that doesn't work. Okay, undo. Keep it like that. Okay. I added the check mark. How to display an element on hover. Oh man. Display none, display block. Hide tailwind. Visible, visibility hidden. Whatever I add to this, I want to add it to here. So visible, invisible, hover, visible. I'm guessing that's how we can do it. Well, that didn't work entirely. Let's see, display none, display block. I suppose you can't overwrite invisible. Plus I'm display. Plus I was talking about display, not visibility. Display. Hidden. I have no idea. Interesting. Regardless, let me have a look. Nope, it doesn't show up. Okay. That's not necessarily good. I'm assuming we override CSS classes when hidden is applied. Nope, that's not it. When it's hidden, it's hidden. Yep, that doesn't do anything either. Let me close some of these actually. Stroke width. That's what I was just looking at. Okay. Maybe I'll just search tailwind. Right, invisible, hover visible. Add this to your config, display group hover. And add group to your parent div and hidden and group hover block to your child element that you want to appear and hover on the element. Apply the block class to this element if there is an onHover event patch on my immediate parent with the class group. Okay. Group hover. When you need to style your element based on the state of some parent element, mark the parent with group and use group modifiers like group hover to style your target element. Activity groups. Hello. To-do list, man. Talking about to-do lists. Let's have a look. That's good, that's good. That looks pretty nice, right? Maybe I want a stroke width of 4.5 if possible. I don't know if that actually did it. Yeah, I think it did. Oh fuck, we'll just keep it. try. Okay. Frame of motion. No. I do have frame of motion. Wild tap. Oops. Oops. While hover, while tap. Stiffness 400. Damping 17. Variance. Scroll trigger animation. Manual animations. Examples. Animation transition. Keyframes. Variants. Gesture animations. While hover, while tap. Okay, it does work. But we don't want spring. We just want straight up. Okay, well that was a 1.1 scaling. Let's do a 1.4 scaling. .2 scaling. I'm just trying to follow the design philosophy of Things 3. Because this is what Things 3 does. I can't show an example, but I don't know if you can see that. Actually, it's so hard to tell. You can do this hover thing, but doing that, right? That's it. Can't do that. I'm trying to do that at least. It looks good, but now I'm just going to change it. So tasks should have not only a title, but complete, completed, true, completed, false, completed, false. Completed, false. If completed is false, what does that mean? Well, how does it do it again? I'm gonna have to bring it up to the side again. Things. Okay, it's like a fill box. Let me turn to light mode for a sec. Yeah, that's sick. It still stays to be dark. I mean light. I gotta change the color of the backing. Is that not going to be harder than I think it is? It's going to be harder than I think it is. Alright. I'm making use of frame immersion already, you know, given that I know only so much. Again, it's pretty cool, but still, how am I going tick, drag out means I don't do the action. Now I've got to worry about state. How can I worry about state? How do I worry about states? Got a tick only. How would you usually care about state? You have to send it to some backend. And you want to maintain that. So it'll have to be a button on click, no? Okay, well, I'm going to just have a little sus at gestures. Button. While focus on hover end, while hover, while tap on tap. Call back when the tap gesture successfully ends on this element. This is what I need then. event, the originating pointer event, touch event, mouse event, or pointer event, and a tap info, which is an object containing x and y values for the pointer relative to the device or page. Complete tasks dot find okay. On tap start, on tap cancel, pan, drag. Okay, it has to be this. JavaScript. Man, this is, you can see where I'm missing some information. What does the event, touch event, have? Mouse event. Event, mouse event. Mouse event. I'm literally just making my own check mark, and it's taken half a day. Okay, mouse event. Event dot mouse event info how to click for motion div. I think I might be using it wrong. It might only deal with certain things. Ooh, I don't know. How do you have a jacket on? We actually don't have heating in this house, so I am wearing a jacket. That's how it works. My hands are super cold. Oh, QWERTY EVV. Sup, man? I don't know how long you've been there for. On the Twitch side. I might keep this as is. Think about how we can color this. BG accent. Need like a green. $9.50. Ooh. 400. $600. $500. I suppose that's all right. The thing is, you can see it overlap. Alright, we're gonna have to think of a better color scheme. I'm gonna think about that later. It's gonna be something in the background of that. Okay, I want to stop this now and do some other work. I will save this first. Okay, I'm going to take a quick 5-minute break and I'll come back to do some more study. I gotta take a look through some of my emails. Who is this? Oh. Oh. Oh, damn. I didn't realize so many new followers. Alright. Well. Let's keep up the good work. Keep up the good work. Alright. Let us ADS, Unimog, CS, APA. APA is the main one. Alright, time to look at some of these lectures. Wrap my head around them. Ooh, there's one other thing that I really want to do. So I have my laptop here. Ooh, hold on. Alright. I have to make an image for the scheduler to keep track of the progress. So we have this image originally. I'm going to make something slightly better. Well, it looks like I can just go directly to the web page because I've kept it on.
At least probably 4, outlets.
I'm going to open up to a new tab. Eek. Say it's just light mode, right? Should I make it dark mode? No, I'll make it system.
I can send you a photo, but you can't see much. The photo is, the outside painted red, and inside there is little bit of
Settings, privacy, security.
And Rhino 90, I think when I search Rhino 90, it comes out with Bon Air.
Settings. Privacy and security. Where's the recording?
Floor plan. I do not have.
Quit and reopen. screen recording.
If you do not do other brand, I don't think it's probably waste our time. Because if you only do private or
Mariami Zedindij. Yeah, I know what you were gonna say, right? Nah, I'm not in Japan. I'm not in Japan at all. It is cold here though. We don't have heating. Damn. Alright, we're gonna have to take screenshots the traditional way. Hello? That's sussy. That's very sussy. Yeah. That wasn't what I expected. Mm-hmm. There we go. Can't really take a screenshot of this. Well, if you start from tasks and you refresh, rip, should go to tasks, not calendar. it's fixable. Very much so. Hey, where are you from? I'm from Australia. I feel like that's fixable, but alright, so I'm going to just use this as something to remember. Alright, so if I do this, I suppose it works the same here. If I refresh, go back. Yeah, it doesn't update this, it just updates it on the change directly. So it should reflect exactly this. So that's another issue to add. Okay, that is it. Ooh. Now we do some study. Let's see. Close this for now. I can probably turn these off for now. Although, like I could. Okay. All right, time to do the study. We can delete all of these now. Just to save some resources. And I'm going to just watch some of these videos now. All right. Hold on.
Welcome to week 2. So in this week we're gonna learn about blind search algorithms and informed search algorithms. Okay, I will start to be more precise and formal, and there are lots of definitions. I'm covering full chapters of a book in a single week. Okay. So there's a lot of content. Take your time to digest it, so watch the videos carefully, and please work hard on the tutorials, because we're gonna practice these algorithms in the tutorials as well in the first assignment. Okay, so back to the material. So remember that I mentioned that state models encode graphs implicitly, okay, meaning that they don't fully project all the states of the graph at first, but rather they start in the initial state and then start uncovering the graph, the search space, while searching. Okay, so which are the three operations of any search algorithm? They're the following. You need to have a start function that tells you which is the initial state of the search space. You need to have a function that detects a goal state when you reach one, okay, the is target, and then you need to have a successor function, which basically helps you to generate the successors of a state. Okay, so given a state S and an action A, it will generate a state S prime. So this function is very important for the operations of expanding a node. Now there is a distinction that I want to make, which is the difference between a search state and a wall state. Okay, in progression, a search state is equivalent to a single wall state. Okay, what is a wall state? A wall state refers to the meaning that we attach to the variables of the state. Okay, so for example, remember that I said the algorithms don't care what the variables means, right? So internally they don't care. We as humans assigned this meaning to the variables. So if I have a configuration of the environment, okay, then for a single configuration of the environment, so for example the locations of objects in a room, that's all there is that is described, then for a single search state there is just a correspondence, one-on-one correspondence to one wall state. This happens if I search forward, from the initial state forward. If I search backwards from the goal state towards the initial state, this is not true anymore, okay? For a single state in the search represents a set of walled states. What does it mean? It means that with a single state in the search, I am representing several configurations of the environment. The reason for that is a bit subtle, but remember that when we define the from the initial variables. So if I have a that we attach search state, which basically helps you to generate the successors of a state. Okay, so given a state S and an action A, it will generate a state S prime. So this function is very important for the operations of expanding a node. Now there is a distinction that I want to make, which is the difference between a search state and a hold state. Okay, in progression, a search state is equivalent to a single wall state. Okay, what is a wall state? A wall state refers to the meaning that we attach to the variables of the state. Okay, so for example, remember that I said the algorithms don't care what the variables means, right? So internally they don't care. We as humans assigned this meaning to the variables. So if I have a configuration of the environment, okay, then for a single configuration of the environment, so for example, the locations of objects in a room, that's all there is that is described. Then for a single search state, there is just a correspondence, one-on-one correspondence to one wall state. This happens if I search forward, from the initial state forward. If I search backwards, from, so internally they don't care, we and a wall state. Okay, in progression, a search state is equivalent to a single wall state. Okay, what is a wall state? A wall state refers to the meaning that we attach to the variables of the state. Okay, so for example, remember that I said the algorithms don't care what the variables means, right? So internally they don't care. We as humans assigned this meaning to the variables. So if I have a configuration of the environment, okay, then for a single configuration of the that we attach to the variables of the state. Okay, so for example, remember that I said the algorithms don't care what the variables means, right? So internally they don't care. We as humans assigned this meaning to the variables. So if I have a configuration of the environment, okay, then for a single configuration of the environment, so for example, the locations of objects in a room, that's all there is that is described. Then for a single search state, there is just a correspondence, one-on-one correspondence to one wall state. This happens if I search forward, from the initial state forward. If I search backwards, from the goal state towards the initial state, this is not true anymore. Okay? For a single state in the search represents a set of walled states. What does it mean? It means that with a single state in the search, I am representing several configurations of the environment. The reason for that is a bit subtle, but remember that when we define the model, we say that we are given a set of goal states, okay? So that set of goal states is typically represented by a conjunctive formula that represents a partial state entailing several configurations of the environment. This subtlety is not needed to succeed in this course, but it's important to know that such distinction exists. In the future, if you ever encounter an algorithm that searches backwards, you need to be aware of this difference. Also, I talked about the search state last week and the difference with the search node, okay? Saying that the search node is just the state plus some useful information. So what is this useful information? Well, typically you'll have, besides the state, you'll have a pointer to the parent, so which node generated the current node, which action was used to generate the current node, and G function, so G is the cost up from the initial state to the current node. Why do you think that we need the parent and the action? Okay, so let's say that I have this node over here, and if I follow the parent pointer, I can look at the action that was used and reach the father. I can use at the action that, look at the action that was used again, look at the parent, and I can go all the way up to the initial state. If I want to retrieve the plan, I just need to read the actions in this direction. Okay, so both the parent and action is just a commodity that is useful in order to retrieve the plan backwards. From a given node, you can always retrieve the path that reached that node. Now let's talk about formal guarantees. Okay, so every algorithm comes with a set of guarantees, and it's important to know which guarantees hold, because it can help you to choose between one possible search strategy over the other. So the first important guarantee is called completeness, and this means the following: an algorithm is complete if it's guaranteed to find a solution if a solution exists. Okay, I'll say it again. If there is a solution, if there is a path in the search space from the initial state to the goal state, and I use algorithm A, then that algorithm is guaranteed that eventually it will find it. Okay? I'm not talking about efficiency. I'm talking that my search algorithm is guaranteed, if I give it infinite amount of time and infinite amount of resources, to eventually find the solution. Okay? There are certain applications that require these guarantees, because you cannot accept not giving a solution. Okay, so this is one dimension that you need to be aware. The other one, optimality, I think that is more obvious. The optimality guarantee is whether the solution, okay, the first solution that the algorithm gives you is optimal. Okay, that's optimal in terms of length, in terms of cost, just optimal. We also need to look at the dimensions of complexity, okay, both in terms of time and in terms of space. We don't use time per se in seconds, because we rather use computer independent measure, which is the number of generated states. Okay, remember that generated states is the number of states that end up in my tree while I was searching. Okay, so remember, expanded states are those that are in the tree. So for example, this is a tree, and let's say I found a solution here. Then all those nodes are the generated nodes. The expanded nodes, I will just draw them in green, sorry, are those two, are the in nodes, the ones that are not leaf, the nodes that its children were generated. So in terms of time, well, we look at how long did it take to find a solution in terms of number of generated states, and in terms of space complexity, sorry, we look at how much memory is needed in order to find a solution. Okay, and this is also measured in terms of states and the amount of memory that you need to store each state. The way to encode those complexity figures is using two parameters, okay? And these parameters are not used just randomly, but because they're succinctly describing the shape of the tree and the size of the tree that I drew before. Okay, so the two important parameters are the branching factor, which tells you if I've got a tree like this one, it tells you on average how many successors were there in the tree for each node. Okay, so it means pretty much you have to look at how many outgoing edges you have from a node. In here, it's pretty clear that we have a branching factor of 2 for every node. If I add another one over here, this will become 3, etc. You can have 2.3 if you want. Okay, but this only encodes for every node that you expand how many children on average you have. The other important parameter is the goal depth. Okay, it tells you at which depth I'm going to find the first goal state. Okay, so it pretty much tells you how deep is this tree. Okay, so depth represents the depth of the tree, because normally you stop once you find a goal state. Okay, so you will find that some algorithms have time or space complexity which is b times d, other ones are b to the d, etc. We are gonna study and understand algorithms in terms of these properties. Before we begin, I want to do a small quiz on what are the pros and cons of using blind search algorithms and using informed search algorithms. So blind search algorithms are the pros and cons of using blind search algorithms and using informed search algorithms. So blind search algorithms only require the input of the problem. That's it. Okay, so I would say that's the first pro of using a blind search algorithm. It's also quite simple to program. Okay, there is no additional input that a programmer needs to encode in order to have a blind search algorithm working. Search algorithm. It's also quite simple to program. Okay, so blind search algorithms only require the input of the problem. That's it. Okay, so I would say that's the first pro of using a blind search algorithm. It's also quite simple to program. Okay, there is no additional input that a programmer needs to encode in order to have a blind search algorithm working. Now, in the con side, it's not called blind for anything. It will always expand in the same order no matter what. Okay, not even if your solution is just one step away to the left. If it's programmed to start always from the right, it will not expand that solution first. Okay, so it's rarely effective in practice. Now, in terms of informed search, you need to program a heuristic function. And remember that heuristic function is like the intuition that guides. The search algorithm. Okay, and someone has to come up with that heuristic function. Okay, and that I would qualify as the con side of informed search, because that's not easy to implement generally, and it's hard to understand the guarantees that the heuristic provides. Okay, and we learn how to do that. On the pro side is that typically having a heuristic function is much more effective in practice. In the next weeks, we're going to learn how to derive this heuristic.
Ahmed A says, what code editor is that? There is no code editor. Yeah, I mean, the only editor that there is a Obsidian, which is my note-taking app. That's about it.
Function automatically.
Yeah, that's Obsidian.
Okay, and that's very powerful idea that hopefully you can use in your future work and other areas that you'll end up exploring. Now, in terms of the blind search strategies that we're going to learn about breadth first search, depth first search, and iterative deepening that mixes the best out of breadth first search and depth first search. We are not going to learn about bidirectional search because, as I said before, I don't want to touch about regression and progression. Bidirectional search basically searches both forward and backwards until both searches meet. Okay, but this is not a key search algorithm typically in planning, so I'd rather skip it and cover other topics. So let's look at breadth first search. Breadth first search is a very simple strategy that always expands the shallowest node first. Okay, it follows the first in, first out order. So let's look at this tree. Okay, we start with A and we expand A, that's the only option. So in white you will see the open list. Now we expand A and we have two nodes. We have B and C. That's my open list. Okay, that's open, and C is part of my closed list. Now in gray you'll see the closed list. Now I could expand either B or either C. Okay, they're both the shallowest options and they're equally shallow. Now I don't care which one you do. Just generally I would say don't do it randomly, just be systematic. Always start for the first one that came into the tree, or always start from the left, just be systematic. Okay, so let's say that we expand B. So now our new search frontier, which is the open list, will be the three nodes, and the closed list will be B and A. And now there is a clear choice. If I'm doing breadth first search, I have to expand node C because it's the shallowest node. Okay, and I will continue this fashion, and now I can expand any of those nodes, and so forth and so on. So remember that we talked about formal guarantees, and we need to analyze which are the guarantees of every search algorithm, because that will help us deciding whether we should go about using that algorithm or not for the problem that we have at hand. So typically we have to study the completeness, okay, whether my algorithms guarantees to find a solution if such a solution exists, and optimality, okay, whether it will find an optimal solution, okay, no matter what. If there is cost, so if all the edges of the costs are the same, are 1, or the costs are not all the same, let's say that this is 10, this is 2, this is 3, and this is 1, is this algorithm optimal? Okay, so think about it and let's discuss it later. In terms of completeness, this algorithm is complete, okay? It's systematic. It will not miss any branch. It will.
Hey Kashidir Odume. Hey man. So the question is, what website is this? Are you learning DSA? Yes. So this is actually my uni website. Unfortunately, I don't know how to share this other than through the stream. And yeah, the thing is, it's interesting that this stuff is coming up timely when I'm learning about binary search and binary trees on Leetcode. So this also helps me on Leetcode, but it was very coincidental. And this is for an AI subject, by the way, which is even more interesting. I'm pretty sure this subject will get more advanced than the binary search DSAs. Not sure if it does get into much else than that though. Maybe graphs, but not sure.
Expand all the possible paths in the state space in the order of the shallowest first. Okay, so it is a complete algorithm. In terms of optimality, the solution here, or the answer is a bit subtle. It is optimal only when all the actions have uniform cost. Okay, what does it mean uniform cost? If all the actions have the same cost, meaning all the actions have cost 1, then it will be optimal. If all the actions have cost 10, it will be optimal as well. But if we have some actions that have different action cost, then there is no guarantee to find an optimal solution if you use breadth first search. Okay, I will let you to think what variant of breadth first search we could use in order to guarantee optimality when costs are not uniform. Okay, and please bring it up on the live lecture to discuss it. If I don't do it myself, think about which variant of breadth first search, so a very similar algorithm that can be also optimal and is blind. The next algorithm that we're going to discuss is depth first search. In a way, you can think about depth first search as the opposite strategy to breadth first search. Okay, so it follows a LIFO strategy. So it always expands the deepest node first instead of the shallowest. Okay, so let's assume that here the tree will never grow farther than depth 3. Okay, there
I actually want to start learning Leetcode, but someone told me to learn DSA before I go to Leetcode. Is that okay? I think it's good to do both at the same time, to be honest. If you ever get stuck on a Leetcode problem because you don't know of the DSA, just look at the solution and understand what DSA is being used, and then just learn that DSA from there. You know what I mean? Make Leetcode your motivator to learn the DSA, as opposed to just learning DSA blindly and then going into Leetcode. It wouldn't make sense. You would be way more efficient if you learned Leetcode while also learning DSA. So do both. That's my opinion.
no successor after depth 3. So we start with our search tree, we expand the first node, then our open list becomes B and C. We expand the deepest node, which can be either of those. Let's say that we'll always expand here first, when we have more than one choice, the leftmost node. Okay, so here we expand B, we go to the next tree. Our choices now are D, E, C, and clearly C is not the candidate. We have to choose between D and E, and since we're going left first, we are going to expand first node D. Okay, so remember, depth first search always goes depth first, okay, as the name says. So this one is easy to remember. Then our choices are H, I, E, C. We can choose between H and I, which is the leftmost. Since we cannot go farther, let's say that H is not the solution, then we will mark it as black and we will backtrack. Okay, so we will go up and then this one gets removed and our choices are I, E, C. Okay, in this case we have only one choice, is I. Let's say that I doesn't contain the solution, then we go to the next tree. So this part has been already explored. Now our choices is E and C. We'll expand then first E, and we will continue until eventually we find a solution. Okay, so you can see the dynamic will be something like that. We will start and we'll go in depth up to the deepest branch that we can get. If there is no solution, we will backtrack one step, go again depth, backtrack another step. Okay, so it might look something like that.
That makes sense. I think I'll do that. Thanks, mate. Definitely following you. Thanks, man. I appreciate it.
And then the tree will do something like that, and it will go back and we'll explore another branch. Okay, so it always goes depth and then backtracks to the next level and try to go depth again. Okay, so this is how the tree would look like. So what I would encourage you now is to think again about the complexity of these algorithms in terms of the guarantees, okay? Completeness and optimality. Is this algorithm complete? And is this algorithm guaranteed to give me an optimal solution when it finds the first solution? Okay, we will discuss this on the live lecture, but I want you to start thinking about this question. Okay, so always that I present an algorithm, think analytically about what are the properties that that algorithm gives you. The last blind search algorithm that I would like to discuss is called iterative deepening. Okay, and it tries to get the best out of breadth first search and depth first search. So it's kind of a mix between both approaches. So how iterative deepening works? It always needs a limit that starts by being 0, okay? So we start with a limit that is set to 0, and then we do depth first search, meaning that we will never expand a branch farther than the limit that we start with, okay? So if the limit is 0, we will try to expand the first node, A, and since its children will be at depth 1, we won't consider them in the search tree, okay? And then once we expand node A and we see that there is nothing that fits the limit, we will mark it as expanded and there is nothing else to do. So if you finish the search tree and there is no solution, what you do is you increase the limit by 1. Okay, so now we'll have limit 1 and we do a depth first search. So we will expand first in this direction, then we will try to expand farther in this direction, but since the nodes at this level are already exceeding the limit, we will not consider them, we won't consider any node farther than here, and then we'll go to the other branch and the same will happen, okay? So if there is no solution limit 1, again, we increase the limit, okay? And we'll keep doing the same thing, so this search tree will be expanded in this way, okay, until we reach a limit where we can find a solution. Okay, so it's that simple. You start with limit 0, you do the first search, never expanding a node farther than the limit that you set. If there is no solution, increase the limit. And you keep doing the increase of the limits until you find a solution. Okay, so this algorithm looks very naive. I mean, it looks like you keep doing the same work over and over again. okay? But contrary to intuition, this algorithm has really good, let's say, guarantees in terms of complexity, in terms of the complexity in time and space, and also in terms of completeness and optimality. And I will again discuss these concepts in the live lecture, but think about it, okay? Try to relate at this point what you know about, or what you think, what you thought about the results in terms of complexity and guarantees of breadth first search, depth first search, and iterative deepening, okay? Try to relate these three algorithms, because this is something that I want you to do first before coming to a live lecture, and then we can work on those details on Friday.
He has to turn down the sound.
Associated with intelligence, abilities like planning and learning. Even though the tasks we give Shaky seem quite simple, the programs needed.
Okay, so you might wonder, why am I starting with this video? Okay, and the reason to start with this video, besides its great music, it's because it marked a landmark on the history of AI, and also on the topic that I'm gonna teach in this video, okay? So these two names, Peter Hart and Niels Nilsson, they're very important in the area of heuristic search, and they are nowadays important because their algorithm that they invented is pretty much in every self-driving car that exists, or that's gonna exist in the market, and it has been used in many autonomous robots. Okay, so the paper that I'm referring to is the following one. Let me show it to you. So this video is from 1972, and actually I recommend you to watch it because it's really enlightening, and it marks, so that projects marked many contributions, and many areas that were studied in this project opened wide focuses of research that still goes on, and many algorithms and inventions that happen in that project, they're still widely used. Okay, so for example, the language that is used to describe planning problems, strips, started from there. Problems in vision, problems in communication, integration of robotics, learning and planning, etc., etc. So this is 1972. One of the key milestones of AI was achieved during this project of Shaky, the first autonomous robot. And one of the papers of the same authors, Philip, Hart, and Nilsson, is called A Formal Basis for the Heuristic Determination of Minimum Cost Paths. Okay, this is the paper that introduced the famous algorithm in AI called A star, okay, which is one of the most widely used heuristic search algorithm. So obviously in this video I'm gonna cover heuristic search algorithms, and I'm gonna start by talking about heuristic functions. Okay, so remember that I said before with blind search algorithms that the only thing that they need is a strategy, a search strategy, decide the order with which they're gonna expand nodes. Now, heuristic search algorithms need another ingredient, basically a heuristic function. And the heuristic function is gonna be the main driving force behind choosing which is the next node to expand. Okay, there are many algorithms under this category. I will talk mostly about best first search. Okay, best first search over here. A variant known greedy best first search because it's very successful when you try to use it in planning, I will also talk about weighted star, which is a variant of A star, the algorithm that was used in Shaky. I will also talk about IDA star, which brings together notions from iterative deepening and heuristic search. And here I just provide the link for Shake. Okay, so these are three systematic search algorithms. There are also local search algorithms. Okay, remember that before I mentioned there's systematic and local. Local just keep one solution at a time, so generally they're not complete, but they still can be efficient. Okay, and one example is hill climbing. In planning, there was this algorithm called enforced hill climbing that was introduced in the area of planning and was really successful, and it's widely used because when it can find a solution, it finds it very fast. There are other instances that you might know: beam search, taboo search, genetic algorithms, simulated annealing. They're all different search algorithms under the category of local search. I'm not going to cover any of them, but you should be aware that there are connections. So what is a heuristic function? Okay, so a heuristic function is nothing else than a function that is estimating the cost of an optimal path to the goal. Okay, so here I'm just showing an example of a search tree. Okay, each of those are possible search nodes. And when we use a heuristic function, what the heuristic function is doing, if I ask the age of this node, so the value, the heuristic value of that node, it will give me this cost estimate of how far away am I from the goal. Okay, so imagine that each of those are just locations in Australia, and this is a place where I want to be, a warm place with nice waves, and this will just tell me some estimate, I mean, in terms of how long will it take me to get there, and I can choose to traverse the branch of the tree that the heuristic value is telling me that it will take me less time to get to that warm place with nice waves. Okay, so this is just an example of what the heuristic function is trying to do. It gives you the estimate cost of the optimal path to the goal, and we're gonna use this heuristic function to guide our search. Let me try to be more formal, okay? And I introduce this notation because you're gonna see this notation in books and papers and articles, so it's good to be precise and to understand how to read these things. Okay, so let's define first a heuristic function. Given a planning task, so this is the symbol of a planning task, think about it just as a model, like the state model that we introduced before, okay? Given a state model and the associated state space, okay? So this is the symbol for the state space of that model. A heuristic function, also called heuristic for short, for a given problem, is nothing else than a function mapping a state, okay, the state from the problem, into a real value, which includes 0, the value 0, and it's only positive, okay, so the positive real values, including 0 and infinite. Okay, so again, it's just a function mapping a state to a number, and not any number, just real values that are positive, including 0 and infinite. Okay, when you see the notation h of s, it just means is the heuristic value of that state, okay, also called h value. Now, a very important symbol that you're gonna see in many papers or books or exercises is h star. Okay, h star is the perfect heuristic. Okay, it will tell me exactly the optimal cost, okay, from a state, and if there is no solution from that state, it will return infinite. Okay, so imagine this is the perfect oracle. For any state, it will tell me exactly what is the optimal cost to reach a solution from that state. Okay, so in a way, h star is the holy grail. That's what we want to achieve. Okay, so that's the perfect heuristic. Now, you should think about heuristic, just to make it simple and plain, as nothing else than a function mapping states to numbers. Okay, many search algorithms don't need any property in order to work, meaning that they are gonna, if you use a heuristic that you build in any possible way, the search algorithm will be correct, a solution will be a solution, and it will find a solution if such a solution exists. That means that it's complete. Now, there are something that that indicates how well the search algorithm will work when you use a heuristic function, and that is how well your heuristic reflects the perfect heuristic, okay, H star. So we will say that the quality of a heuristic function, or the informedness, or how informed is a heuristic, is basically how close is your heuristic from the perfect H star heuristic. Okay, so if the true optimal distance to a location is 10, I will measure how good is my heuristic with respect to how close my heuristic guesses the correct value of 10 for a state. Okay, and you will measure, of course, for all the possible states that are in your state space. Now, some algorithms like the one introduced in Shaky, you can prove some properties, okay, some guarantees. Remember that when I talk about guarantees, always think about completeness, optimality, time complexity, and memory. You can prove guarantees depending on properties of the heuristic function. Okay, and we will discuss these properties in a minute, and then we'll discuss how these properties affect A star in the next videos. For other algorithms, the best that you can say is just it works. Okay, so it's almost an art to come up with good heuristic functions, and in certain cases it pays off to analyze them in order to understand what do they give you. Okay, in terms of an important heuristic that we're gonna be talking about when we look at how to come up automatically with the heuristics, there's a heuristic called H plus. Okay, H plus is a lower bound of H star, and it will become more clear how useful is H star. But in planning, when we think about how informed is a heuristic, we will look at how close it relates to H star as a surrogate of as how close you get to H plus as a surrogate of H star, okay? Because there are some properties that are really good about H plus. So I said search performance depends crucially on the informedness of the heuristic. Any other property that you may think of that can be really important about the heuristic in order to make the search algorithm to perform well? Okay, think about that. Is there any other property that the heuristic function needs in order to ensure that the search algorithm works well? So, of course, you need to think about how expensive is to compute the heuristic function. So if you're gonna compute the heuristic function in every state that you encounter, well, you want that computation to be cheap, okay? Because otherwise it will be too slow, your guidance. So extreme cases that you should think about it. H star, imagine that you want to use H star to guide your search. Well, it will work very well to inform which is the branch that you have to navigate, but informing every state, so computing the perfect heuristic in every state, is as costly as solving the full problem from that state. Okay, so you will end up solving the full problem from every state along that path that you find using the perfect heuristic. So perfect heuristic, it's computationally expensive as solving the full problem. Okay, so it might not be that useful in practice. There is the other extreme, where you set all the values of your heuristic function to 0. Okay, meaning the heuristic will always tell you, you know what, I don't know anything about the distance to the goal. So this heuristic is extremely cheap, it's constant time, there is 0 computation, but it's useless, right? It doesn't help you deciding which node to expand next. Think about which algorithms use H0, okay? All the blind search algorithms, inherently, they're using H0 because they never think about how much distance there is to the goal when they make a decision on which node to expand next. So there is this trade-off about how informed is the heuristic and how expensive computationally is the heuristic. Okay, and there is a lot of research on how to trade off these two competing interests, and I'm happy to point you out for some introductory papers on that topic, and we will learn about few of these trade-offs that pay off in practice. Okay, there is a lot of research on how to trade off these two competing interests, and I'm happy to point you out for some introductory papers on that topic, and we will learn about few of these trade-offs that pay off in practice. Okay. So let's define now the properties of heuristic functions that then we're going to use in order to prove properties about heuristic search algorithms. Okay, so there are four of them, and the first one, it's called safe. Okay, you say that a heuristic function is safe if for any state that it gives me an infinite value, it means that there is no solution. Okay, there is no solution, it means that the true H star, okay, is also infinite. Okay, so I'll say it again. If I have an infinite in my heuristic function, so if my heuristic function tells me, look, from that state, it's not worth looking further because there is no solution, then I can trust that my heuristic is not lying, okay, because it really means that H star is also infinite. There is no solution. Okay, so that's the safety of a heuristic. It never lies, and if you see an infinite, you can stop the search from that branch onwards because there is no solution. Now, goal aware means the following. If I have a zero value, I can trust that that state is a goal state. Okay, which means that if I have a goal state, it will always have heuristic value 0. Okay, so a goal state always has a heuristic value 0. So I can just look at the values of the search state and I can assume that it can be a goal state. Now the next property that is important is admissibility. Okay, admissibility means that your heuristic is a lower bound on the perfect heuristic. Okay, for every state on your search space. In a way, think about it as having an optimistic heuristic. Okay, so it means that always your heuristic will say something optimistic. So if you think about distances, so how long does it take to go from Melbourne to Sydney or to any other city, then if your heuristic is admissible, it means that it's a bit optimistic. It will always tell you that it's a bit faster than what it really is. Okay, so that's the property of admissibility. A heuristic is admissible if it's a lower bound for every state of the state space on the true distance, okay, on the optimal distance. Now, consistent means the following. A heuristic is consistent if given a transition, state, action, and S prime, which is the next state, the resulting state, then the difference of both heuristics is never larger than the cost of the action. Okay, so you could rewrite this as right. You could look at okay, so the cost difference between the parent and the child is never bigger than the cost of the action that was applied. Okay. Interestingly, these properties relate to each other. Okay, so you can prove certain relationships like the following one. So given a planning model and a state space, then you can say that if your heuristic is consistent and goal aware, okay, so if the first two properties hold, then it entails that the heuristic is also admissible. Okay, so it's sufficient to prove that it's consistent, that is consistent and goal aware to prove that is also admissible. Okay, then if it is admissible, then it means that it's also goal aware. Okay, and the last one is that if it is admissible, it also means that it's safe. Okay, and there is no other implication that you could prove. Now we could spend a full lecture just going through these proofs, but I rather move on into other material. I will leave it to you as an exercise, and you can ask any question. And I think it's a good exercise just to understand the relationships. Okay, so if you cannot come up with a full proof, just try to convince yourself that those relationships make sense. Okay, you can do it through an example. We can discuss it in Piazza. Code. So let's define now any question, and I think it's a good exercise Finally, we can start looking at the algorithms that were used in Shaky. Okay, so our first heuristic search algorithms. So I know that it's not that didactic to show pseudocode, but the reason why I'm showing you pseudocode is to show you how simple are those heuristic search algorithms. Okay, they fit in one slide, and they're generally not that hard to program. So I'm gonna walk you through this code, pseudocode, line by line, so it becomes clear what it is that behind any heuristic search algorithm. Okay, so the first line defines the open list. Okay, remember that the open list is the search frontier, so the leaves of your current search tree, and we define the open list as a priority queue. Remember from your classes on data structures, priority queue is a heap. Okay, generally you define it as a min heap or a max heap. In this case, we're gonna use a min heap, meaning that the top of the priority queue will be given by the heuristic value of the states in the priority queue. So basically this is saying that we define an open list where the open list is sorted by the heuristic value of the nodes. Okay, this is the nodes and this is the state of the node. Then at the beginning the open list is empty and we insert the first node. Okay, so remember that at the beginning, a few videos ago, I mentioned that there are 3 operators that we need in order to define any algorithm in search. There are the ones in blue. You need to be able to name the initial state. You need to be able to define which is the goal, okay, and the successors of a given node. Okay, so these are the 3 operators that we mentioned before. Okay, so initially you create the starting point and you insert it in the open list. Okay, so now the open list only contains the initial state. We define the closed list as the empty set at the very beginning, and this is the main loop. Okay, so the main loop is saying while my open list is not empty, I will keep searching. Okay, while I keep having candidates to explore, I will keep searching. Now I will stop obviously if I found a solution, but otherwise I will keep searching. So the first line of the main loop is basically popping up the best node in the open list. Okay, so this is the one that defines the search strategy, right? So it's saying I will pick for expansion the node with the minimum heuristic value. Okay, so that's the best node in my open list. I will check whether I've expanded that state before. Okay, so closed, check for duplicates, whether I've seen that state before. And if I haven't seen it, I will just record it as a state that I'm going to expand and that I've seen already that state. So it belongs to my interior part of the search tree. I will check whether this state is a goal state, because if it is a goal state, I should just return the solution. Okay, that's it. I found a path from the initial state to the current node, and the current node is one of the goal states that I'm trying to achieve. If it's not the goal state, I will do the state expansion. Okay, so this is the operation of expanding a state. For every successor of this state, which is defined by the next resulting state and the operator that you use, the action that you use, you will create a node. The node will have some information. Who is the parent? Which action I've used, and which is.
That scared me for a second. Thanks for the follow, official Sammy from Twitch. Because it came up twice. Okay.
Node, okay, and this is the resulting node. If the heuristic value of the new state is less than infinite, I will insert that node in my open list. That means if my heuristic tells me that there might be will do the state expansion. Okay, so this is the operation of expanding a state. For every successor of this state, which is defined by the next resulting state and the operator that you use, the action that you use, You will create a node. The node will have some information. Who is the parent? Which actions I've used? And which is the state of that resulting node, okay? And this is the resulting node. If the heuristic value of the new state is less than infinite, I will insert that node in my open list. That means if my heuristic tells me that there might be a solution from that state, well, I should consider that state as a possible node for expansion in the future, okay? So I will just insert it on the open list. So if you want to think about it as a pictorial depiction of how would that work, we start with the initial state, we put it in the open list, we will pick it for expansion, and I will expand a couple of states. I expand the initial state. Okay, this is already expanded. I have two candidates. In order to know which is the next candidate to expand, I will just look at the priority queue and I will pop up the best node according to the heuristic value. Let's say that is this one over here. I will expand it again. And now my open list will contain these three nodes, and my closed list will contain these two nodes, okay? And I will keep creating the search tree until I find a solution. If I've expanded all the nodes in the state space, so if I've marked all of them as expanded, okay, then what I will return is just that the problem has no solution. Okay, so this is basically what there is behind any search algorithm, and specifically heuristic search algorithms. So note that the key ingredient here, deciding which is the next node to expand, is given by the heuristic function. So the previous algorithm that we explained was called greedy best first search. Now the reason why it was called greedy best first search is because it only looked at the heuristic function in order to decide which is the next node to expand, right? The only difference from greedy best first search to A star is that the nodes in the open list now take into account another term, okay? So the nodes in the open list take into account the cost of the path reaching the node, okay? So this is the past, and also the future cost, okay? So how long will it take me to reach the goal, okay? So this is typically called f of the state, which is expressed as g of s plus h of s. This is also known as the evaluation function. Okay, evaluation function. Now this is the main difference between greedy best first search and A star. A star doesn't only look at the cost to go, so the heuristic function also takes into account how much you had to pay in order to reach that state. And every node will then be expanded, taking into account these two functions. Remember that when we said the contents of a node, I said before the node has a parent, has the g function, the cost basically to reach that state. This is where the cost to reach that state plays a role, okay? And that's why we need to save it in the node. The rest is the same. The only difference is this part over here, okay? So let me explain this part, what it says. Remember that before we were checking if a state is a duplicate, meaning that if we expanded it already, okay? And if we already expanded before in greedy best first search, we don't need to expand it again. We don't need to consider it again. Now in A star, there is an exception. If you've seen that state before, but the path reaching that state, okay, so this section over here, the path reaching that state was worse than the current path that you have in the node, then you should expand it again, okay? So pretty much you should think about it as, let's say that I have here a path to this node over here that I will paint in green, and let's say that the best g for this path is 10, okay? Meaning that the best path that you knew so far to that node was 10. if now I get another node, okay, that goes through another part, but this path is smaller, so meaning that the g of this path is, for example, 7, then even if I'm trying to expand the same state, the green state, since this path is shorter, I should nevertheless expand it again. Okay, that's the only difference. So two things. Now you take into account the g function. 2, you re-expand a state if the g function is better than the best g that you knew to that state. Okay, these are the two main difference with greedy best first search. Now, at this point, I would encourage you to think about the properties that we discussed before, right? Completeness and optimality. When greedy best first search is complete and optimal, and when A star is complete and optimal, given the properties that we know about heuristic function. Okay, so try to say things like greedy best first search will be optimal if the heuristic is satisfy the property of being goal aware. Okay, think about the relationships between the properties of heuristic functions and the properties of search algorithms. Okay, completeness and optimality. Okay, we will discuss this on Friday, but I want you to start thinking about those concepts. So let's look at an example of how A star expands a search tree. Okay, so let's say that here we've got the first term is G and the second term is H. Okay, so at the beginning we have that the cost that I have to pay to reach the initial state is 0. Okay, I don't have to do anything to reach the initial state. And my heuristic is telling me that I'm 3 steps away from reaching the goal. Okay, the heuristics are just made up by me. This is just for the sake of the example. So let's say that now I expand the initial state and I get 2 nodes that are added to the open list. Okay, so now this section over here is my open list. This section over here is my closed list. Which is the next node that A star will expand? Okay, so I encourage you to stop the video now, think about it, and play again. Okay.
Which node will A star expand? I'm guessing it's the shorter. So the red.
So we have to look at these 2 terms. So here this is 3, this is 4, and remember that we are in a min heap, in a priority queue that always expands the smallest number. So the node that will be expanded first is this one over here. Okay, so we expand that node. Now my new frontier, the open list are these 3 nodes, my closed list are these 2 nodes. Which is the next node to expand? Okay, stop again, think, and play again. Okay, so I look at the summation and it's clear that this is the smallest number,
yep.
So this will be the node that will be expanded next. So I expand again. This is my closed list now. This is my open list. I choose again the minimum one, which is this one. I will do the same thing. My open list now is this shape. So it's this, always the frontier. Okay, so imagine in your head it's always the leaves of the tree that you've seen so far. Again, I will expand the smaller one, which is this one. Now I have my new frontier is the following. Okay, I haven't found a solution yet. Remember that to find a solution, I have to expand the goal state. Okay, so now I will look at which is the smallest node in my open list. And in fact, if you do the summation here we'll have that, let's say the cost is 4 plus 0. 0 means that my heuristic is goal aware. And it's clear that the next node that will be expanded is this one over here, and we will at this point, A star will stop and find a solution. Okay, so let's look at A star in practice, okay? So how A star works in practice. I'm going to show you a video by Sebastian Thrun. Sebastian Thrun is a famous researcher, scientist, entrepreneur. He invented, also a good educator. He invented Udacity. If you're familiar with Coursera, Udacity is another platform for education, for teaching courses. He did a lot of contributions in AI. I mean, SLAM algorithms that are widely used in any autonomous robot. He was the precursor of those algorithms. And he was the first one that managed to finish the DARPA challenge. Okay, so if you clicked on some of the videos that I put on the first week material, I mentioned DARPA challenge as one of the competitions that was driving the research in AI. So this is Sebastian Thrun explaining the algorithm behind their, let's say, pathfinding in their self-driving car that finished for the first time the competition in DARPA. Okay, so I will play the video for you.
So here's an actual implementation from the DARPA Urban Challenge, the Stanford car, trying to find a way to a maze. And as you can see, the maze is changing as the car moves. This reflects of the fact that the car uses its sensors to see obstacles, and obstacles are sometimes occluded, and the car can only see them when they're nearby. What's really remarkable here is that the car is able to plan really complex maneuvers to the goal. At any point in time, you can see its best guess of a path to the goal. And the orange trees are A star search trees. They aren't exactly grid trees. Our car moves differently from a grid-based robot. It can turn at different angles. And each of these little steps is a different turning angle combined with a different forward motion. But leaving this aside, you get these amazing trees that find paths all the way to the goal using A star.
Note that here the search trees have a depth, okay? So they decided to stop at a given depth and go along that path, the best path that they found so far. So the one with the minimum heuristic.
This implementation is so fast that it can plan these paths in less than 10 milliseconds for any location in this maze. That was faster than any other driving team that I know of at the DARPA Grand Challenge or the DARPA Urban Challenge.
So something that he hasn't said so far is which is the heuristic function that he used, right? So remember that any heuristic search algorithm needs a heuristic function, okay? He will tell it in a moment, but think about which kind of heuristic functions you could use in such a setting.
The planning is repeated every time the robot cancels the previous plan. You can see additional adjustments at place at times. But as you go through this video, you can see how A star planning with a simple Euclidean distance heuristic is able to find a path to the goal. When you implement this yourself, the big difference to our grid implementation is a different motion model. You have to implement a robot that is able to turn, and you have to write on the math of a robot that's able to turn and go forward. This robot also can revert, so going backwards is a discrete different action. But other than that, it's essentially the same A star algorithm you just implemented. So if you want to build a self-driving car, you understand to make a really complex, nice search algorithm to find a path to a goal. So this is a scene where DARPA trapped our car using a barrier that went all across the street. So the only way for the car to navigate this was to take a multi-pole U-turn and had to plan this all by itself using A star planning. The car pulls up to the barrier, realizes there's no path to go, then invokes its A star planner and comes up with a turnaround maneuver that is not particularly elegant, but it's super effective. And the car was able, in this competition, by itself, to turn around using A star, find the optimal plan to do so, and move on. Otherwise, it would have been stuck forever behind this obstacle. In this final video, I'll show you a parking situation where the car has to back into a parking space between two other cars. And you can see how the obstacles are visible, how these other cars are visible, and how our vehicle Junior navigates an actual parking lot. Again, this is using A star. It finds its way optimally into this parking spot, backs in and backs out again all by itself. The planning time for each of these A star runs is less than 10 milliseconds. And the car was able to competently do this, even though in advance they had no clue where the obstacles were and where the parking spot was. That is A star for robot path planning. And what you've implemented yourself is the core of it. Again, if you want to turn it into a real robotic motion algorithm, you have to change the motion model, and you have to see the next class I'm teaching you when I go to continuous.
Okay, so the remarkable thing here is that A star, the same algorithm that was used in Shaky, is used here for the DARPA challenge 40 years later. Okay, now I need to make a clarification. A star is not looking over the continuous state space. Okay, so it's not a motion planner. When he said a motion model, is because when you have to look at the low level control of the motions, you need to use a different technique. Okay, so A star is looking at an abstract discretization of the space, and is considering, when it says an A star planner, is considering also high level tasks. Okay, so the backbone of this planner, okay, that makes the sequential decision making, is a search algorithm plus a heuristic function. Okay, so that's why search algorithms are so important for autonomous systems. Okay, they are one of the parts, the key components of any autonomous system resolving sequential decision making problems.
Alright, it's time to read a little more. Live lecture. The quiz is for self-assessment. Reading. This material is freely available. Chapter 3 of this classic book. Sure. Interesting links. I've seen this already before. Shaky the robot, fair enough. Animation of graph BFS algorithm. I'll have a look at this. I'll have a look at that as well. This is the exact same. Let's have a look. What is this? Breadth first search.
Please subscribe to my channel. You'll see an icon in the lower right to do that, and you'll receive notifications when I post new videos. Thank you.
so generic that all people have bad handwriting. In the field of, I don't know, the field of PhDs. Like, what is this? Const? I can't understand what that is. Cost. So G of the state and the action is equal to 1. And the heuristic is equal to 0. So initial state and goal state. In the graph below is the heuristic. Consistent, goal-aware, admissible, and safe. It's all 4. The goal-aware heuristic assigns H0 to all goal states. Yes. What is safe heuristic? It's I'm gonna have to save these questions. These are good questions to have. So what is a safe heuristic? If a solution doesn't exist from state S, then Hs is equal to infinity. If a solution exists, solution does not exist, Hs greater than infinity is incorrect. Heuristic functions estimate the distance from a state to the closest goal state. Consider general search problems. Which of the following are true? Code that implements A* tree search can be used to run uniform cost search. Yes. A* tree search is optimal with any heuristic function. Is complete with any heuristic function. Zahib Hassan, hello again. Bro, you still live? Yep. Let's go. I'm gonna copy some of these questions over to Obsidian. A* graph search is guaranteed to expand no more than DFS. I'm not sure about that. The max of 2 admissible heuristics is always admissible. Hold on. Okay, the max of 2 admissible heuristics is always admissible. That's true. A heuristic that always evaluates to Hs is equal to 1 for non-goal states. Non-search nodes, S is always admissible. It doesn't mean anything. 1 doesn't mean anything particularly. Alright, it's fine. I know I got some wrong. And I'm fine with that. If a solution state exists, That makes sense. The closest goal state. With any heuristic function, well, I guess, you know, only if the heuristic is safe. If the heuristic is not safe, then it can assign to all nodes that lead to a solution. I see. Yes, you need to set fn is equal to gn. Correct. Then it follows that the max is correct. Okay. All nodes we can get greedy first search to become depth first search and uniform cost. Interesting. I'm gonna have to remember these questions. Okay, and then put it here. I also need like what is explain the difference between world states and search states. Classification of search algorithms. What are the classifications of search algorithms? What are the 4 metrics we need to understand between? What are the 4 metrics we need to understand in search algorithms? These are time complexity, space complexity, completeness, and optimality. What are classifications of search algorithms? World states have meaning, whereas search states are have meaning. Search states are for the agents and have no meaning beyond what we give it. But we don't give it anything. It's kind of vague. And then I have to add all these questions. So if we set the heuristic hn to 0 for all nodes n, What does a star become? Uniform cost search, which apparently is DIJK Stra's Dijkstra. I'm guessing that's Dijkstra's algorithm. However, whoops, we need to link to this quiz if we want to understand where this source is from. Wait, C I quiz 2. Yeah, there's more to come. I gotta write some more. Okay, I'm gonna keep this now the way it is. I will come back. I just need to go have some dinner now. So, taking a break. Catch us in a bit. Okay, I'm back. Sky Caffeine. Thanks, man. Shocked that you're still here, to be honest. It's a very good book. Wow, this is crazy. Crazy long. What is this? Bibliographical and historical notes. Is there questions? Interesting. Alright, planning agents. It's fine. Just got to do the tutorial. Let me write this down. APA, watch lectures, do quiz, I've got to do the tutorial. CV, there's reading of lectures I can do. I could set up workshop 1, which I'm going to do tomorrow. APA, I'll do the tutorial tomorrow. That would be it for that week, I think, for APA, besides the lectures. And then CV, set up the workshop, but also read the lectures. And I could attempt workshop 2 as well. And CS is something I've got to figure out. Don't want to fall behind on CS. Cryptography and security, that is. Mad. Sure, so I did this. Yeah, week 2 stuff is out now. This is pretty much the main thing that I got to focus on tomorrow. fast modular exponentiation. Oh wow, you learn it from Khan Academy. I suppose that's like an extra understanding. And then there's a week 2 quiz. Same thing. So CS stuff I gotta do first. Then I do CV stuff, then I do the tutorial. And then we can do any scheduler development or Leetcode. Nah, I'll do Leetcode first still in the day, tomorrow. But the rest of the day would look pretty clean. I can do that. So I have all that I need for this now. And I know what I'm going to do tomorrow. I'm going to save the bookmarks and then close tabs, save the bookmarks, and then close tabs. And then we're just going to open up scheduler and do more scheduler stuff. Alright, close this tab. We'll keep that tab open, sure, why not? Okay. Right, I haven't finished these, so I gotta finish these first. I'll finish them by the end of by Friday. Right. It'll be done by then. And then we'll have a new paper. Alright. For now then, we shall continue with ShadCN. I mean, schedule. Alright, let's have a look. So I understood frame of motion, I understood grid. Task icon change on hover. Green tick animation on complete. That's something I'm doing. Similar to things 3. How possible this is. Yep. Okay. Also have to consider shortcuts. Alright, and then I'm going to open up this. Okay, here's another thing I'm going to do. I'm going to apply to one of the banks. Bro, you gotta learn Tailwind CSS. I mean, that's what I'm trying to do. That's what I'm trying to do. Why don't you follow a tutorial? Well, I'm following a tutorial for just learning CSS, right? So I reckon learning Tailwind is just looking at the docs and understanding your CSS. And then over time, once I do enough Tailwind, I'll just pick up from it. You know? You will love it. I mean, yeah, I probably would. Do you have any recommendations? I'll check them out off stream though, probably. Item center. It's all fine for the grid aspect. Tailwind CSS course by JavaScript Mastery. It's on YouTube, yes. JavaScript Mastery, I see. Two and a half hours, so almost 3 hours. Yeah, I see. From India. Play for some time the video. You know, yeah. Let's have a look at it for like at most 5 minutes. We'll have a quick look. Yeah, the intro. There would be an intro. Yeah, let's see the intro.
Have you ever wondered how to make your applications look stunning with minimal effort? If so, you've clicked on the right video. Today, we're diving into Tailwind CSS, a revolutionary tool that uses but why stick around to the end? Well, by the end of this video, you'll have mastered the foundation of CSS, but also created a stunning website ready to improve your portfolio and chances of landing a job. Now, many additional secrets, tips, and tricks will also be scattered throughout the video, so you can truly take your web
Hopefully
development
that's better.
skills to the next level. This is not your typical crash course. We're going to do it JavaScript mastery style. The first part will teach you how to make the most out of Tailwind CSS, how to fully understand how it works behind the scenes, all of the best practices, different themes, as well as how Tailwind is going to allow you to achieve tasks that usually require JavaScript code, and so much more. But then, in the second part, we'll put all of your newly gained Tailwind skills to the test by building a beautiful Nike landing page. You'll create a uniquely designed website with a navigation bar, complex hero section, popular products, about us, special offers, testimonials, newsletters, and a big footer. And of course, the entire website is completely mobile responsive, all with the power of Tailwind. After you develop this app, I'll even teach you how to get your own domain name and deploy to the internet so you can share it with your friends, potential employers, and put it on your portfolio. Now, that's a lot to take in. And for that reason, along this video, I've created a complimentary Tailwind CSS starter kit that includes 3 things. Number 1, a quick reference guide. Number 2, a list of all the best Tailwind CSS component libraries. And number 3, a complete ebook that guides you through Tailwind CSS from basic understanding to advanced techniques. It's filled with examples, tips, and best practices, acting as a companion guide to this video. Just click the link in the description below, and the Tailwind CSS starter kit will be on its way to your inbox. Now, without any further ado, Tailwind CSS is a recent sensation and a highly popular utility-first CSS framework that aims to simplify the process of creating modern and responsive web interfaces.
And then I'm guessing that's the intro done. And then intro to Tailwind CSS, how the Tailwind CSS works. The domain name, how to get a domain name, sponsored probably. Crash course. Project setup, building the app, creating components, navbar, hero section, shoe card. Epic. Very nice. Code and load. Keep up the good work, David. Thanks, man. Will do. So Zahib, this is very good actually. I'm probably gonna go, I can't speak. I'm probably going to do this at some point. It's actually pretty good. I will save this. Into watch later. I think I hear an echo. Maybe I'm speaking too close to the microphone. Hopefully that's not... I don't think I can hear anything else, can I? It could just be me speaking too loud. Just do it right now? Nah, man. I'm not gonna do it right now. It ain't happening. But because I'm already I already need to know what I need to know. But this is good to get a further understanding of Tailwind, which I will pick up when I do more front end. Alright. Plus, I might want to do it in one sitting. It's already 8:30. Oh, there's a sound coming from two sources. Let me have a listen from an external device. Give me a second. Code and load, I think it might just be you. Because I feel like when I heard myself there, it seemed alright. Is it because it could be that you have two devices open? I mean, not two devices, two screens of my same thing. Highly doubt, but anyway. Alright, but Zahib, I already added that to watch later, so I'm gonna be doing that at some point as well. But also what Sky Caffeine said was right. You know, I feel like if you know CSS, Tailwind, you know Tailwind 2, so you don't need any courses and you can just refer to some of this. Oh damn, sorry, I have your stream open in two different browsers. Sorry dude, my bad. That's funny. So I was right. Nah, you're good. You're good. Alright, let's have a look. So give me a second, it's getting a little loud here. I think I know CSS to a well enough level. Now though, only recently, I would say. doing the Odin project, that is. You know what I mean? If I go to the Odin project right now, you can see the I guess my level of understanding technically. So if we go to foundations, basically all of the foundations part, right? As the basics. Sorry about the sound. Okay, that's actually good. HTML and CSS course from the same guy, JavaScript Mastery. That's a good one. All right, I will check that one out too at some point. So let me put that as a save. Hey man, it's right, there is nothing wrong with background noise like that, don't worry, at least I'm okay with it. Maybe adding a noise cancelling filter on OBS will help. Yeah. HTML and CSS. Thanks Code and Load, by the way. It just gets a bit loud sometimes, don't want to break the ears for you guys. JavaScript, Mastery. Is there actually a filter that you can do directly on the mic? Probably. Let me see. Advanced audio properties. No, I'll figure it out later. I'm guessing it's this one. And alright. Let me have a quick look at this. Oops. Again, just the intro. This looks alright. See how much really I'll need to know here.
Hi there, and welcome to a project video where you'll build and deploy a beautiful website using HTML and CSS. we'll create a uniquely designed sushi ordering landing page with custom animations, with a navigation bar, a creative hero section that invites the user to feel the taste of Japanese foods, an About Us section, popular food section, trending sushi and drinks, as well as a newsletter sign up and a footer. This sushi website is the best HTML and CSS project-based tutorial that you can currently find on YouTube. Oh, and I almost forgot. The website is entirely mobile responsive, which means it'll provide your users with the best experience, no matter which device they use. Whether you're just starting or consider yourself an intermediate developer, mastering the fundamental building blocks of the web is crucial to your success. Why bother learning HTML and CSS when libraries and frameworks like React or Next.js are available? By diving into the fundamentals, you will gain a deeper understanding of the building blocks that make these libraries and frameworks so powerful, allowing you to leverage them to their fullest potential. After you develop this app, I'll even teach you how to deploy to the internet so you can share it with your friends, potential employers, and put it on your portfolio. You might be wondering, what are the prerequisites for building such a fantastic website? This course is entirely beginner-friendly. Think of this as your first HTML and CSS website. Alongside building this application, you'll learn the most critical technologies needed to build any website: HTML, CSS, Visual Studio Code, animations, mobile responsiveness, JavaScript, and Vite.
Hey KFC.
We're going to start simple and then move to more complex concepts as we go. I'll explain every step of the way. In this video, you will gain knowledge on various topics, including the use of CSS variables, importing CSS files into other CSS files, understanding and effectively using flex and position properties in CSS, creating smooth and subtle animations to enhance user experience, implementing the BEM method for naming classes, maintaining a well-organized file and folder structure, and embracing the principles of writing clean code and much more.
Clean code.
If this video reaches 20,000 likes, I'm recording more HTML and CSS videos. Also, based on your requests, I've compiled a valuable resource outlining the Visual Studio Code extensions that I personally use. This comprehensive guide includes essential tips and recommended extensions that can significantly enhance your experience as a developer. And the best part is that you can access this resource.
Alright, yeah. Fair enough. I mean, I don't know how likely I'll need this one specifically, but I'll keep it in the watch later. Mainly because, you know, I've done the Odin Project, parts of the HTML and CSS. Okay. But now, I gotta make this functional. If I look here, tab has mouse event. Due to user interaction with pointing devices such as a mouse, touch event. An event which the state of contact with a touch-sensitive surface changes. This surface can be a touch screen or a trackpad. It's fine. And pointer event. It's interesting. So the state of the DOM event produced by a pointer, such as the geometry of the contact point, device type that generated the event, the amount of pressure that was applied on that contact surface. Interesting. Bro, what do you do to become a developer or something else? What do you mean? Oh, are you just asking like what am I trying to achieve? I'm just thinking like I guess having a full stack well-rounded understanding of web dev. So, you know, I want to be a full stack developer, I suppose. at the end of the day. But also I just want to build a good app. So that's like my main motivator, to build something cool. And so it's going to take time, and you know, even today just doing like a checkmark button has taken the whole day to do. Do you know React Native? No, not yet. And I plan not to worry about that until I've gotten a web app out, you know. But I feel like it would not be too much more difficult to learn than from React, I reckon. But yeah. So event info tab info from frame emotion. Cool. Wait. Okay. After you got pro in web dev, you already 75 knowledge for mastering React Native. So you can make cross-platform mobile application for both iOS and Android. Just by single code, yeah. Yeah, that would be good, right? That would be epic. The other alternatives that I've learnt about was like I dabbled very little about it, but it was Dart and something else, but it was a Google specific thing and not, you know, Facebook based like React is. It was Dart and something else, I forgot, but that was also cross-platform. Damn, I can't believe I forgot that. Yeah, Flutter and Dart. Yeah, right. Just leave them. Okay, yeah. Fair enough. Just go React Native. I think so. It makes sense also, given that I'm building in React right now. So. Yeah, learn React Native. It's more good than Dart and Flutter. Alright. I'll take that advice. I think I agree. Alright, what do I want? What's in a mouse event? Right? And what's in info? Point is the only thing. What do you even use on tap for then? Otherwise, the Dart and Flutter path is completely from each other, and React Native as well. I don't know what you mean by that. Oh, completely different, right? Fair enough. If it's completely different, then yeah, I think React Native might be best. What is this for? The hyper sound says, "Bro, you are working hard but not smart. I'm gonna tell you 3-minute video to watch. Trust me, it's gonna help you a lot." I mean, we'll have to see about that. We'll have to see. How to Learn Any Coding Language in 10 Days by Amin Bagheri. Alright, give me a sec. Let's see. Alright, fine, we'll do a React video. We're a React channel now. This is the last video. It's a hype.
When I learned my first programming language, I spent months doing tutorials, learning syntax, and killing time. But now, with AI, things have never been easier. I was able to learn web development and launch a full-stack website in literally just 3 weeks. And I used to be an iOS dev. Here's how. Step 1, you gotta learn the syntax. This is the building blocks of the language you wanna do. For example, if you wanna learn web development, you gotta learn JavaScript. Make sure you select a course that just purely goes over the actual coding language and has a project or two at the end, just so you feel accomplished and are motivated to get into the second step. Now, key tip here, you need to use AI as much as you can. And ChatGPT, most of the time when it comes to syntax-related issues, will solve it for you. So don't waste time on meaningless bugs. We want to move as quick as possible here.
I kind of disagree with the ChatGPT. I won't lie. You can use ChatGPT to get the syntax, sure. But it's also about looking through the documentation to know where that syntax comes from. That's also why, I don't use ChatGPT much.
This step should take around 1 to 3 days, depending on how intense you work. So now you have the building blocks. Now it's time for step 2. You gotta learn the stack. What is a stack? Well, let's say you want to build a website. The most popular stack out there is MERN, MongoDB, Express, React, and Node, right? If you learn these frameworks, you're able to build a full stack website. If you want to build an iOS app, you got SwiftUI, Vapor, and you got a database of your choice. But one word of caution, this is where most people end up in the purgatory known as tutorial hell. A lot of people can spend months where they do tutorial after tutorial, never actually accomplishing anything. So here's how to do this properly. Make sure the project that you select is a project that includes things like an API, things like a backend, fetching data. Don't just build a to-do app that's very simple and gets done in an hour. And then once you've done this first course from start to finish, following the guide, then pick another one, do it again. And by the end of this, you would have built 2 proper full stack apps or websites that include a back end, a front end, and you're pretty much good to go at this point. So depending on how fast you are, this step could take anywhere from 5 to 8 days. So now, here comes the juicy part. Step 3, building your own projects. So now you're pretty much ready to start building your own projects, but you still haven't mastered any coding language yet. So in order to truly get up to speed as quick as possible, you want to make sure you're using AI as a crutch as much as possible when you're building your projects. So for example,
I still doubt that. I still doubt that philosophy.
if you want to make a piece of text bold, AI is a perfect example for this. Simply drop in the text, get back the code, and then you would have learned that that specific key or tag or whatever it may be is necessary to make the text bold. And then next time, you wouldn't need to do so. So at the beginning, you want to use AI like a crutch, kind of like a walking stick, and then eventually you're going to wean yourself off of it to truly master the programming language. And now you should be able to go ahead, get started, and literally be building real-world projects that can be used by hundreds of thousands of people in mere days. Enough wasting time, enough of tutorial hell. If you want more coding and tech entrepreneurship videos.
Here's the thing, right? It makes sense what he says, most of it. I would only disagree with the AI part. You shouldn't be using AI when you want to get the foundations right. That's my personal belief. And, you know, because when you get ChatGPT answers, it might just be me, but I always overlook the solution that ChatGPT gives. And with that comes no learning, right? You can use it as crutch all you like, but at what point do you not use it as a crutch anymore? That's something you just have to consider. And the point where he says that, you know, the stack section, where you look at 2 long tutorials that'll give you the full stack build, that's also a good video to watch. I think like what he said there was fine, but that I guess basically boils down to doing practice, having practice. And you know, even if you build a full stack app, I feel like sometimes it could still take a little more than just building the app, because you might just be copy and pasting whatever the tutorial person is just telling you to copy and paste, and sometimes people just overlook the answers. The other thing is there is a little bit of a haste in terms of what he wants to build, right? You know, you want to get it in 10 days, but honestly the thing is, maybe you just want to build good code. Sometimes you just want to build good enough code that other people will appreciate reading. And that doesn't come within 10 days, that, at least for me. So that's what I can say. Bro, this guy himself learned web dev in 10 days. Of the specific stack. Yes, he did. Probably. Swiftbucket.com, this is the website he built. Let's see. Swift boilerplate with 70% of your next app already done for you. That's a big claim. Is it really a good app that you make if 70% of it is already done? You know what I mean? Pre-order. Not a bad app indeed. Not a bad web app, I mean. Web page. But yeah, I have my skepticism, you know? Alright, that's it. No more videos. The web page looks different of your side, or it might be, it might just be the apps that I had open. Oh, sorry, the extensions. Yeah. still regardless. Okay. Gotta understand some frame of motion on tap example. Releasing enter will trigger on tap. I'll help you enable noise cancellation in OBS? Sure. Thanks for your input too, Pino. Select audio source in the sources box. Yeah, I see. More CPU usage, low CPU usage, low quality. Alright, fine. We'll try RNN noise quality suppression. Click add and give it a name. Add noise gate option. Click the plus button under audio filters. Select noise gate from the list. And give it a name. Yeah. I don't seem to have noise gate, to be honest. Okay, never mind. I do have noise gate. There's also a noise suppression directly. Hello, hello, hello. You've literally copied and pasted these. Adjust the filters as needed to get the best sound quality without cutting out your voice. Yeah, to be honest, I don't think I need noise gate. I want you guys to hear my keyboard sound, you know, keyboard tapping. But I enabled noise suppression. Yeah, so I have noise gate as well, but don't think I'll use it all that much. Let me see if I can type. My typing doesn't get picked up. Let me see. I think that's a lot better, but still, I want to see. All right, let me have just to play around a bit. Let me disable noise gate. Whoops. I'm assuming you can still hear that. You can still probably hear some. Yeah, there's a lot better than this, but it takes time to set up. Yeah, maybe I can look into that later as well. Yeah, but for now, I think this is good then. I disabled the noise gate, but hopefully you can still hear the typing. Let me just give it a sec. Try with monkey type for a second. Ooh. Alright, pretend. Let me just hear it back from another device. Yeah. I see how it works, but it's also cutting out the noise of the keyboard. Damn it. We'll find some better noise suppressions. Actually, let me still enable it for now. Okay. Should be okay. Except yeah, you can't hear any of this, but it's alright. We'll figure it out. Just close the page. It's 9:09. That's ugly. Okay. How is this even useful? Yes, that is the Logitech Pro X Superlight. Is it? No, it isn't. Wait, is it? It's the Pro Wireless. Logitech Pro Wireless. FPS shooter mouse, basically. I think it is the Superlight, actually. I think it's the same. Mm-hmm. Controls. I think it's not Superlight as that one weighs 63 grams. It could be. Yeah, it might not be actually. What is the normal Logitech Pro Wireless without Superlight? Oh, this is the normal. Yeah, okay. Yeah, so this is the one that pros use. The CS pros use. Anyway. What is how to use on tap manual motion? Still not getting it. I'm still not getting it. DPI 800, I think. X. And tap. That took up forever. Yeah, that's good, right? Oops. think I'm... Introduction to frame of motion. Damn. You know, what you work hard as on stream, but for 10, 11 hours, but the productivity is not that much great. I'll tell you what, it's only in this amount of time. Only during the last few hours of the day, what can I say? I'm trying to figure out this little problem, which at the end of the day is still a problem that you have to solve. It's just difficult to find a solution. I'm just gonna think, right? Have a closer look at some of these examples. See. So you still use on click, I suppose. Just I suppose. Unchecked. Might be what you do here. So instead of a motion button, let's make it a button. Then make this into a motion div. I could. No. Because I just want the button. Yep. See? Unchecked is going to be this. But unchecked props and unchecked props. You should use AI for learning. Like I said, man, I don't use AI. Well, I mean, I do, but I don't want to use it for this. It'll just lead to possibly worse code than what I've already written. In the sense that it's probably less maintainable. Because I'm gonna refactor this later on once I've just gotten functionality. And then I'll push it into a PR. So on click, it's not assignable. So yeah, this is because I don't need that. I don't like that. What are your favorite commands, motions in Neovim? You have a good point. One is :right. One is control : quit W or WQ, right quit to get out of Vim. My favorite motions, I guess you could say RCIW, to change in word. There's also just hitting the what's it called, the star symbol, or sorry, the dollar symbol to get to the back, and then hitting the it's not the hash symbol, it's the up symbol to go to the front, back front. And if you look at my layout, it's actually, look at my keyboard, I'm actually just hitting like 2 buttons that are spatially memorized. This one and this one. That's how I always know to go back and front. So I'm always using that to jump back and front. CIW to change in word, or you can pretty much match that with anything else. CI this to change all of inside the tag. You know, there's CI whatever. It's pretty good. Okay, bro. It's your choice. Okay, bro. I gotta go. Have a good night. See you soon. Bye. All right. Bye. There's a hide. Catch you in the next stream. Yeah. What can I say? These are my favorite motions. Control W. I mean, yeah, Command W. Alright. I should also maybe try and do something like keyboard button tracker. Like ones where it transcribes all the buttons you press on your keyboard. That might be cool to have. It's pretty much a key logger. As unsafe as it is, but you know, you can see me typing in my password. I don't understand how you can move fast at the end and at the first of the line. Yeah. It's basically 2 symbols, right? The 2 symbols are the caret symbol and the dollar symbol. So if you just hit those 2, you go, if you're hovered on one specific line, you can just go back and forth between the 2 sides just by hitting the caret symbol and the dollar symbol. Like hitting the caret symbol for going to the front, hitting the dollar symbol to go to the back. That's it. On click unchecked. The props Okay. Here's the thing though. What is in onChecked? What is meant to go in onClick? Whoops. That's like... Oh wow, I think your keyboard is special. We'll do that, I need to click keys. Click... two keys. Oh right, yeah, okay. I mean, for me, technically I am hitting 2 keys. If you can't see it, it's because my thumb is actually holding down the special key. I'm actually I'm hitting this bottom right key and then hitting the value. Left, right, left, right. But otherwise, if I just hit left, right, left, right, left, right, it just starts typing letters, right? It's because there's a layer key that helps me change the caret symbol, change the usage, yeah. So you see, when I let go, AF, 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 when I press down on the right with my thumb, changes to the $ and caret symbol. Yeah, so the more you know. It's the I guess it's the power of this keyboard. If you look at my back behind me, behind the screen, you would see a few cheat sheets of literal key mappings. Just because everything is blank keycapped, you know, there's different layers of the keyboard. I could literally just show you real quick. Check it out. Can I even draw this? Yeah, here. See that? Those are all the things that I see. There's more on this side as well. Yeah. That's pretty much. Okay. I've only posted for the motion things. Oh yeah. Hey, that's still, I mean, still, you have some cheat sheet. Is it too cold there? Evangel Ron Kato says it. No. I mean, yes, it is. What can I say? We don't have heating at home. So I have to wear pretty warm just to sit down all day. You know what I mean? Actually, talking about sitting, I should be standing. Located in Australia. Living in Australia right now. It's cold. I'd say it's not. I guess it's not too bad. It's still like 13 degrees. That's crazy. I'm in Turkey at the moment. It's crazy hot. I wouldn't be surprised. That's up there in the northern hemisphere. Okay. Here's the thing. What do I put as unchecked? It is a mouse event. Oh, target.index. I undo everything that I just did. Event to target. Okay. Man. Give me a second, guys. Now, okay, console.log. Maybe I'll just do that. Okay. See what it's like. Event is undefined. Oh, it's on click. I didn't even read that type of parameters. Types of parameters are incompatible. array. Hmm. So I'm just speaking to someone as well, typing on the device. Okay. Berta Walnuts, hello man. Thanks for checking back. I'm really almost out of it now. It's just something I'm stuck on. Yeah. On tap. Darn it. Alright, we're just going to open up VS Code real quick, see if we can get some more inspiration. That is by using the crutches of ChatGPT. Whoops. Oops. So weird. Info.index. Index. Current target. Possibly no. We'll see. Let's see if we can do anything about this. Nope. Yeah, no, the way I'm handling React is very unreact. Okay, I'm gonna call it a night. Fuck this. I'll figure it out. Figure it out tomorrow. We'll come back with a fresh mind, and we'll call it for tonight. Thank you for joining, guys. Appreciate you staying for so long, and thank you to Sky Caffeine for staying for so long too. I was doing React a lot today too, I'm guessing. Yeah. Too much. Alright. Thanks for joining, and I'll see you guys tomorrow most likely. Catches.